Hello, everyone, and welcome to a decade of innovation with Aurora Livestream. We're so excited that you're here with us. We are going to talk about Aurora's present, past, and the future. And we have a solid lineup for you today, and it's going to be a jolly good time. To take you on this journey, I'm your host, Aditya Samant. I'm a Principal Database Specialist Solutions Architect, and I work with the star of the show, which is Amazon Aurora. And here with me, I have my good friend, Adrian.
Hey, Aditya. Hey, everyone. My name is Adrian San Miguel. I'm a Principal Partner Enterprise Architect here at AWS, and much like Aurora, I'm coming up on a birthday as well. It's a couple months away, but, I definitely feel my age.
Well, happy birthday in advance.
Well, thank you.
Awesome. Well, now, it's been 10 years, a little over 10 years since Aurora was initially kind of, talked about. What was your experience back in the day like?
Back in the day, it was kind of interesting. I remember when I was a WETAM, early stage partner SA, Aurora had just launched. We were trying to figure out, hey, do we coalesce around this? Is this something we advise partners to go out and do? And those partners that took that bold risk with us, they co-engineered, co-built with us, they were the ones that were able to leapfrog effectively everybody else offering DBAs as a service. It's kind of interesting to see how it started and where we're going. It's I'm kind of humbled that I got to have a bit of a role in that progression.
Yeah, and we would love to hear from you, the audience, if you were around back in the day when Aurora was introduced, and what were your feelings like? Because RDS was still around, and Aurora was just getting introduced. What did you think of it? Did you think that it was going to get so far as it has? So let us know.
Yeah, valid question also, chat. Thanks for hanging out with us wherever you are. Let us know how long it took you to figure out that Aurora was originally a... Do you remember what that is? What that trivia question was?
Sorry, I'm blanking on it.
Do you remember the code name for Aurora?
Do I remember the code name for Aurora?
Yeah.
There was actually a bunch of code names, but the storage code name was Grover.
I remember that. I remember that. And while we're remembering, let's take a little look at the past, because I remember exactly where I was when this announcement happened. Chat, if you remember, let us know. So hang tight. We got something for you real quick.
Yeah.
I am very, very excited to announce the launch of a brand new database engine called Amazon Aurora. And Aurora means a new dawn. Aurora means new dawn. We've been working on this for 3 years, and this offering will be fully MySQL compatible, but it'll have 5 times the performance of the typical MySQL implementation. It's at least as available and durable and fault tolerant as the enterprise editions of the proprietary commercial database engines and high-end SANs. It's highly scalable, it's highly secure. It's available through our relational database service, RDS, so you get all the same management capabilities that you get with our other 4 engines in RDS. And it's a tenth of the cost of the leading commercial database engine solutions.
Wow, Aurora, a new dawn. I mean, it's unbelievable that was actually 10 years ago. And if you hear Andy, he was talking about, it's at least as good. But we have come so far, right? It's pretty much better in every possible way. The performance, the availability, just the scalability. And we're going to talk a lot about that today. And, I keep coming back to you about what did you think about all of this back in the day? Like, I know you're just a smidge younger than Aurora. I want to say like 6 months younger than Aurora, but it was still early days.
Yeah, it's absolutely early days. Even just getting a lot of these traditional DBAs that have been clacking away code in a dungeon forever, get them to understand, hey, this is MySQL compatible. It was earth-shattering for them. I remember talking to partners and saying, no, we can't invest the time and effort and energy to go train this thing, and nobody's going to want it. But once we started teaching them the art of the possible and helping them understand how the storage layer was built out, the I/O contention would be less of an issue, and you get to use a lot of the same skills, it was a game changer.
Oh my God. And, it started with a simple paper. Like it was just a storage paper. And having anything distributed in relational database back in the day was such a big deal.
It was.
And things have changed since then. Now we have distributed databases, just bespoke support for distributed databases. By the way, Aurora also has a bespoke distributed database. We are going to talk about that in one of our segments.
Okay.
So wait for that. It's just a teaser. But back in the day, like having storage on distributed, like a distributed foundation, was a big deal, and it was a big bet too.
Yeah, absolutely. That was probably the hardest thing as an ops person. Go set up the storage layer, work with the DBA, understand the requirements, protect it, rate it, DR, back it up, prove it. Now that that's been distributed and kind of abstracted away, it's a win-win for everyone.
Yeah, and now that we have come so far, let's see what Andy has to say now about Aurora. Let's hear from him.
Yeah, please.
Hi, this is Andy Jassy, and I'm happy to be with the team today to celebrate our 10-year anniversary for Amazon Aurora. Aurora and this milestone is a good example of what happens when you take a step back and think about what customers really care about and then work backwards from there. And so if you go back in time 10 years ago, even before 10 years, several years before that, what we realized was that customers were caught in this pickle where they wanted the performance and the availability and the reliability of commercial grade databases, but they didn't want to pay the price that they extracted, and they didn't want the austere licensing terms. And so we thought about that and we asked ourselves, why do customers have to make that trade-off? And so the team went about building from the ground up in the cloud a new cloud database called Amazon Aurora. And what Aurora did was it gave developers and builders the performance, the availability, and the reliability of a commercial grade database, but at a much lower cost and with all the flexible licensing terms of open source databases, and was compatible with MySQL and Postgres. And so it has been very useful for our customers. We have hundreds of thousands of customers using Amazon Aurora. And the team, of course, hasn't stopped innovating. We've innovated and built all sorts of features. But even just look at what we announced last year at reInvent and then just recently released in Aurora DSQL. And so here, what we found was that builders wanted to have a version of Aurora that could be even more available. And so DSQL is 5 nines of availability, it's multi-region, it's strong consistency, it's very low latency, and then it also allows our customers to be able to run the most highly performant applications in a reliable way, but with that same balance that we've given them, which is commercial grade databases with the pricing and the flexibility of open source databases, all Postgres compatible. So I'm excited. I'm very excited to recognize this milestone. I'm very thankful, not just to the team, but to really our hundreds of thousands of Aurora customers. Thank you for all the feedback and the guidance that you've given us. Thank you for being Aurora customers. And what I can assure you is that even though the 10 years is momentous for all of us, we're not done. We're not done asking ourselves why we can't make this better for you. We're not done listening to your feedback. We're not done inventing, and we're not done building. So here's the next 10 years together. Thank you.
Excellent. Well, good.
Man, I was going to say, you took the words out of my mouth. Thank you, Andy. That's pretty insightful. Aditya, I know you have a little bit of a checkered and happy history with Aurora as well. Why don't you let us know?
Yeah, I've been working with Aurora for the last 5+ years, and like Andy said, we are not done innovating. But we today have a very special guest, the OG, and like we, lovingly refer to him as the father of RDS, the father of Aurora, Grant McAllister. And as much as we want to talk about the future, we want to start where it all began, the innovation of storage. And Grant is going to talk all about that. Grant?
Thanks, sir.
Welcome.
Yeah, as I said, my name is Grant McAllister. I'm a senior principal engineer on the RDS and Aurora team. I spend most of my time on Aurora these days, but it's been quite the journey, and we've really come a long ways in the last 10, 15 years.
We have.
For those of us that managed databases back, 20 years ago, is handcrafting an individual machine, and ordering it and waiting 6 months to get the machine in and, doing all this stuff. And,
we tried our best, Grant, to get those machines out.
Yeah, exactly.
And I would love to hear from audiences. What are some of your horror stories from back in the day about the storage and the databases and installations? Let us know.
Yeah, exactly. So, we kind of have that classic architecture from back in the day where actually, most of the drives were actually attached directly, via SCSI and weird things that like people have even forgotten about. But, sort of in a sort of modern classic model is what we built with RDS. And so I'm going to walk through, sort of how we thought about where we were with storage and then how we thought about what we wanted to do. So I'm going to show you this short little presentation just to walk you through that. So on the left, we sort of have a classic architecture. It's still like a good architecture, but there's reasons why we wanted to do something different.
Yeah.
So on the top, you kind of have the head of the database, the sort of processing unit. So when you do a commit as a customer, what happens is you're going to write. And at the time, this was typically to one availability zone before RDS. This was very innovative at the time, was to do multiple availability zones, or MAZ, or is what we call it inside. Yep. But the things you're doing is you're writing all the blocks. You got a checkpoint. So there's a lot of work going on, logs, archive logs. There's a lot of processing that had to write. So that pipe was pretty important, right?
Yep.
Now behind the scenes, typically you weren't just writing to 2 copies because that's not enough durability, right? So you would do chained replication, and that's what I'm showing here. Is that extra copy is chained together. So at that point, you do this because you don't want to have to send 4 times the bandwidth down to the storage, but it does end up with some interesting effects because you have to wait for these acts to come back from storage, right?
Yep.
And that first act gets done, the second one gets done, but let's say this third one kind of stalls for a second, right? Well, that means you've got to wait for that to happen.
Yeah.
And so that can cause a lot of jitter or long tail latency in your application. So it's waiting for that commit. Finally, it happens. You get the commit back to your application. You can process something. So this works pretty well, right? Like, don't get me wrong. Like, it's a standard architecture. But when we started reimagining what we wanted to do with databases in the cloud, where we were going to disaggregate like how the system worked and move more intelligence to storage, we're like, we have an opportunity to change this model, right?
And back in the day, this was kind of revolutionary, that change or the decoupling of compute and storage too.
Exactly. And so there was many things that come with this, and I'm just going to talk about this one specifically, which is really around latency and jitter reduction. There's a lot of other pieces that other folks can comment on, but so you start with the same head node, and again, this is all open source Postgres compatible, right? So there was no big difference. Like, that was one of the key selling points that I really pushed on Aurora was if we want adoption, we've got to be open source compatible, right? Because I think that was just real key for our success. So we do that commit. And instead of sending these things down, we send 6 copies right away. Now, the big difference is it's only logs, right? So all the things like checkpointing that always had to happen, now we're doing that in storage, right? So that's super important. This allows us to have the bandwidth to send those 6 copies all at once. So when those acts start coming back, we don't have to wait for them in serial mode, right? Like, they can all come back in parallel. And so as soon as we get to 4, we can actually, because we're a 4 of 6 quorum, and we talk about this a lot with Aurora from a durability perspective, that we picked 4 of, that we needed this 4 of 6 quorum for durability. And there's lots of debate about what the right number is always on these things, right? But we don't talk about this in terms of jitter reduction that much. But by only having to wait for 4, that means if these other 2 for some reason take a little longer, you don't care. Right. They'll get done. We'll correct them. We'll do repair if necessary. But it means that act back to the customer happens more consistently, right?
And I remember the first time I saw this slide, Grant, had to have been maybe May 2016. That this was like, I remember my mind being blown in our compute technical feedback community, and just seeing that decoupling and understanding the hows and whys. It's a game changer. There's no really other way to put it.
Yeah, and some of this was based on just things that we wanted to do because we knew the system, but a lot of it was also based on we were running RDS and we were getting feedback, that sometimes we get jitter and, customers who were super latency sensitive. And, it'd be interesting for folks, that are watching to kind of comment about, if they had those kind of experiences with databases where, they had problems where they had a lot of jitter and, was causing problems with their application.
Yeah, and I also remember that one particular graph, I don't know if you have it, but the comparison was the regular database versus Aurora and how the Aurora's I/O response is always going to be smooth.
Yeah. Well, let's actually look at that. So what I'm going to do is I'm going to switch to showing a little bit of a live benchmark
demo
here.
time.
Yep.
Yes.
Yeah.
Have you done the demo dance yet? I strongly encourage you to do the demo dance.
The demo dance?
Demo dance. It's interpretive. You know, it can be a shimmy, it can be a shuffle, it can be this guy. It doesn't matter. But we do have to placate the demo gods every single time.
Yes, I know. So there's always that fun. So what I'm going to run here is I'm going to run sysbench, which is just a common benchmarking tool that we use. And in this case, all we're doing is an update to the database. So we're doing a single update with a commit. So we're just measuring kind of the write latency for commit. So on the top, I have labeled as multi-AZ. So this is our RDS multi-AZ offering. And so we'll just get that started. And on the bottom is Aurora with our standard I/O offering. And this was the original offering that we had that has been around for 10 years. So what we see is we're just running one thread. So this is like not really realistic to a production workload. And we see that the latencies are fairly similar. Like the MAS is a little higher, but it's not a lot. Like 1.5 milliseconds here, if I can highlight, versus 1.2.
Yeah.
And a lot of that's coming from the fact that we're writing to 2 availability zones. So just speed of light. We'd love to fix that one, but I'm good, but I'm not that
Darn
good.
physics.
Yeah, exactly. Yeah. So this looks fine, right? Like if you looked at this, you'd say there's not much difference between those systems. But as the folks that are watching know, real systems run a lot more work.
Yeah.
So let's run this now with 1,200 connections, which is kind of cool because back in the day we would need a very, very big box to do this, and now it's quite easily done on lots of different systems that we offer. So we've started that. It takes a little bit more time for the threads to start working. But we'll start seeing latencies. And so on the bottom again, we have Aurora, right? And what we're seeing is our latencies are in this nice sort of sub 10 millisecond range. Now they're still higher. They're still up in that sort of, we'd love to see 2 milliseconds, but we're seeing, but we're also doing like 153,000 writes per second, right? That's pretty impressive, right?
Yeah, it is.
And what we see up top here, MAS also can do similar numbers, like in 150, 160, right? But we're also seeing these kind of numbers, right? We're down to 92. And our latency has jumped up to 34 milliseconds.
Yeah. That's that jitter that you were talking about before.
Exactly. And this is because that's checkpointing happening, and that's causing more work for the I/O subsystem, and that can cause jitter in those systems, right? So you can kind of see that we, and again, this is at very high load. So this isn't something necessarily you're going to see all the time. This is kind of a very pushing benchmark, right?
Yeah.
Yep.
But it's the kind of thing that we like to think about because we want our customers to be able to scale and not have to worry about these kind of problems, right? So this looks quite good, right? And this is why we did what we did with Aurora. But as we've always said, we always are innovating, right? We're always thinking about what we want to do next, right? So let's just, I'm gonna stop these benchmarks and let's go back to that slide. And so what we're doing today is that commit latency is what we're talking about here, right? That's the thing we're trying to improve. And that's the difference between when you run the commit and when you get that ACK back, right? So that's what we wanted to improve even more than we've done already. So in standard I/O, what we're doing is when that write comes down, we actually wrote to memory, and then we had to do a bit of processing to actually get it to physical storage before that ACK happened. And for a lot of applications, this is perfectly fine. But if you're very write intensive, then this takes a little more time. So about 2 years ago, we made a new offering called I/O Optimized. And at the time, this started off as I think, we did some changes to a batching so that we knew people who wanted I/O optimization would get those. Okay. But it was also a price performance. So we changed the pricing model so it was, again, better for folks that were doing a lot of I/O. Yep. But I always had the vision that we wanted to do more with it. We wanted to continue to improve. And so just this year with version 17 of Aurora Postgres, and this will be coming out to more versions shortly, but we added this thing called the log store. So the log store now sits, and when a write comes in, it goes directly to the log store, and it's durable. So this really reduced our latencies. So let's go back and look at what that does in comparison, right? So let me just bring, so on the bottom again, standard. So if we run, again, this new I/O model with one thread. Okay. Now, what do people think we're going to see? Is it going to be drastically different?
Yeah, what do you folks think? Let us know.
Let us know in the chat, please.
Yeah. So at one thread, as you might expect based on what we talked about, there's not much difference because it's a little faster maybe, but it's in like 0.03 milliseconds. Like most humans can't even notice that, right? But again, we're not really worried about when you're running one thread, right? What we want to be able to do is we want to be able to run something like this with 1,200 connections, right?
Okay.
So now when we're running this, so again, what we were seeing was, 9, 13 milliseconds. We were doing, 140, 150,000 TPS, right? Wait for that to stabilize. We're now seeing 300,000 TPS. So essentially double.
That is amazing.
And the reason it's double, right, is that the latency is so much lower. And when you think about that, right, for a single-threaded application, how much work you can get done is directly proportional to that commit latency, right? So by reducing this dramatically, that makes a huge difference to the performance you're going to get, right? And the thing you'll notice is, the change, and this latency, by the way, is the P95 of the latency. Like the average is actually much lower than that. And so this is very smooth, right? Like we're seeing very consistent numbers, and you'll get some jitter here because I'm connecting remotely with my application to do this benchmark. So just all network has a tiny bit of jitter.
Yeah. So let me see if I got this. So predictable pricing.
Yeah.
Lower latency.
Yeah.
And higher throughput, right?
Yes.
Like this is all checkboxes.
Yeah.
All checkboxes. I mean, I'm old enough to remember, Grant, and I'm sure you appreciate this given your background, being told, hey, I need a 1 million IO capable database and I need it provisioned in this exact same way. And our P95 is 2 milliseconds, and anything more than that is going to be a sub-zero type of ticket.
Yeah.
Being able to get that without having to do that entire rigmarole, letting it take 18 months to get hardware, build, rack, stack, et cetera, doing that in the command line this fast with that type of performance is huge.
Right. And so what I'm showing here is at scale. And this is one of the biggest things about relational databases, that people always have a lot of fear of not being able to scale, right? So this is one of the key tenets that we work on as a team, is we want to reduce that fear, right? We don't want you to have to think, oh, I have to do something different. You just want to be able to be get a slightly larger box, or in the case of serverless, just, have it do something. So here we see
if I may.
Yeah.
It's a bit of a story, show and tell.
Yeah.
I told you I was full of surprises, and this is a true story that I promise is entirely true. I remember a couple Super Bowls ago, there was a customer that was going to do a large advertising campaign tied to the Super Bowl, and I remember getting paged the night before saying, hey, we're starting to have some issues. How can we scale? We very quickly bailed out and got onto Aurora and ended up pushing something like 4 million IO.
Yeah.
At peak, I forget how many hundreds of thousand transactions per second, and it went off without a hitch.
Yeah.
And the partner and the customer were not only delighted, they were actually kind of surprised at how easy it was for them to get going, because they were thinking, I got to get a bigger box, as opposed to changing the way they were doing things.
Yeah.
And if you go back to what Andy was saying before, or at the launch, it was, we're going to do at least as good as the open source. We have come so far away from that, we're doing better.
Yeah. And so just to kind of show you, what I was showing before was we had scale, right? But let's say you just need to do the 150,000 TPS, right? Well, now what you can do, instead of running 1,200 connections, you can run 300 connections and get the exact same performance, right? So for your application, that probably means you need less application boxes, less workers. So that saves you money as well on the system. So, and what we see now is, look at this latency that we're getting. We're getting 2 millisecond latency from this system.
Wow.
Right? So that's dramatically different. So at 300 workers, it's really almost the same as when we were doing one thread, right? And isn't that what we always want? We want a system that's very predictable, right? So if you're not pushing the very edges, now with the new IO optimized, you can get basically latencies that are super similar to what you're used to, even at low concurrency. So as your application scales, which is what we all want, right? We want our businesses to keep growing and need more databases. That's the positive thing about being in this business, is you want everyone to succeed. So so now the thing that's interesting here, because this is all storage based, right? And we're running this workload, what I can go do in the background here is I can go and I can kick off a clone on this database. So this is, the command is restore DB cluster to point in time, but we have a flag here that says restore type is copy on write.
Okay.
So let's kick this off.
You're cloning while the production load is running.
Yeah, exactly.
Oh, the level of panic and sheer terror this would have inspired me 10 years ago.
Yeah. So typically you might see, a tiny, we might see a little bit of bump in latency, but not really. The way this works is so good in that, because all of it's happening at the storage layer, where we do all the heap management, so that these commands, whether you're doing a backup, a clone, global database replication, all these features work at the storage level, and we've done it so that there's no disruption. Versus,
well, I have actually had customer conversations where customers would ask, "Are you certain that you're telling me that if I take a backup during production, it's not going to affect me?"
Yeah.
Oh, yeah.
Yeah, and so I think those are the things that we've been working on, over the last couple of years. But as always, right, we want to do more.
We want to do more.
Yeah.
Innovate.
Yeah, exactly. So, some of the challenges that the team's working on right now, we've had some discussions around customers who put a lot of data into single clusters, right? And they like to do this, even though they could put it in more, is just a manageability. They like to have everything together, especially when you talk about, let's say you want to do global replication or something where, hey, if you want to do a switchover, you want all those things to go with, one application, right? But the management of all that data inside that database, again, can be very challenging. And so we're working on things with the storage layer to help customers better manage large databases, have more flexibility of how they do backup and restore. So that's just one piece of one of the things that the storage team's working on today. And when I say storage team, really it's not like we produce a storage feature, right? Because in the end, their database features, they just happen to be storage focused.
Yeah, and this actually is a testament to the founders such as yourself, is that 10 years ago when you were building it, the hardware was much slower. The memory was limited, and we continue to build on that foundation, and things just keep on getting better.
Yeah.
So it's just kind of amazing to see that what we built so many years ago, we still keep building on top of that.
Exactly. When we started Aurora, an R8 was the biggest box, right? So you look at that now, and we're at 48 XLs, right? So just making those work well, that's a lot of work. When we say innovation, it's sort of like just keeping up with the future, right? Is innovation to one degree, and then leapfrogging in front, is a totally different thing. But it's what the team's really passionate about.
Yeah, and I don't think we have actually shown everything here too, right? This is just the basics. I know some of the things that we have added is the tiered caching using NVMe, and that's also part of the IO Optimize. We just keep on going, and I think the IO Optimize reads and writes the tiered caching. That was released last year.
Yeah.
So we're just getting started.
Yeah, and again, it's places where we think we can help customers. And that's where we really want, if you have an area that you say, hey, look, I'd really like you to innovate in this. This is what we like to get back. Whether it's one-on-one customer chats or when I go to reInvent, I love those, talking with customers because we get this feedback. And sometimes we have specific, things that we're working on. We either are tweaking those or going in different directions based on that customer feedback. It really is critical to us.
Yeah, so we want to hear from you. Tell us what you want us to build next on Aurora, or the Aurora storage, and we're happy to take that feedback.
Yeah, and it's not just storage, right? If it's engine things, whether it's, you have a problem with, whether it's MySQL or Postgres, there's different pieces there. We love innovating at all levels, and we like to work with the open source teams because we want to make sure that in general that MySQL and Postgres continue to improve and get better, and so we like to feed back into the community those changes as well. So
awesome! Thank you so much for your time, Grant. Really appreciate it. Really cannot say thank you enough for all of the work that you've done and continue to do. Chat, we've got a survey for you. We've got a little bit of a incentive. The first 3,000 viewers who respond will get a $20 AWS credit.
Nice.
In that survey, let us know what you think about Aurora, the problems, the issues, the things you would love to see. Anything is fair game. We want to hear it. Feedback is absolutely a gift. And again, Grant, thank you so much for hanging out with us. And coming up next, we've got a segment on scalability. You probably don't want to miss this one.
So after launching Aurora Postgres, just the adoption was incredible. It was just growing so much week over week, and that told the story. How it made me feel, it was exciting but busy.
It was just a pride that knowing that the services and the engines you build really help customers. For all the things we've built, I think that's always the prime motivation. So when you talk to customers, especially at something like reInvent, where they come up and really are excited to use the service, that's, just gets a lot of pride.
I don't think there is a moment when I discovered Aurora is a hit. It happens gradually over time. I think I always was confident that we're doing the right thing in Aurora. I'm glad we were right.
Hey everyone, welcome back and thank you so much for continuing to hang out with us today as we celebrate Amazon Aurora's 10th anniversary. My name is Adrian San Miguel. I'm a Principal Partner Enterprise Architect here at AWS and joined by my good friend Aditya. Say hey.
Hey folks, my name is Aditya Saman. I'm a Principal Database Specialist Solutions Architect, and I get to work on the star of the show, that is Amazon Aurora. Now, speaking of star of the show, next we're going to talk about everything scalability. How do you scale up? How do you scale out? How
What
do you
is
scale your
scalability?
reads?
What is?
What is scalability? Well, I don't really know, and that's why we have our next SME, the next OG, David Wine. David, do you want to introduce yourself real quick?
Hello, everyone. Hey, guys. How you doing today?
Good.
Hi. Yeah. So I'm David Wine. I'm a senior principal technologist on Aurora, and I've been around nearly as long as Grant, but I have been around for the creation, the launch of Aurora Postgres, and have been sort of just a lead engineer on the team. Then managed the team here and there, and then had the great privilege of leading the development of the Aurora Postgres Limitless database. So,
Yeah.
Wow, that's a mouthful.
Yeah,
Yeah,
and you know, really, the database technology, the foundation, that's all great. But a database is only as good as its scalability. Can it scale? Just like for the PC gamers out there, can it run Crysis? It's kind of like that, right?
Yeah.
So what can you tell us about Aurora's scalability?
Yeah. So the scalability was actually one of the first things. You know, it's funny. I looked through my email and I found my very first week at Amazon back in early 2016. I sent Grant McAllister, who we just heard from. I sent Grant an email. I'm like, hey, so I just joined this team. I'm supposed to be working on performance. Let's talk about that.
Okay.
And so Grant and I have been working on scalability of Aurora for about 10 years. And in databases, obviously, its performance is so important. But scalability can come in lots of different dimensions. And so one of the innovations that we've worked a lot on is our serverless scaling. So this is in-place scaling of the compute to go along with that detached storage scaling that you saw earlier. There's some really great innovations in there. We're going to poke at those today. I'm going to give you some demos there. Another key aspect of Aurora architecture is read scaling. So can we scale our reads in addition to scaling our writes? And then once all that is done, we built Limitless database, which lets us scale then writes across multiple systems. So in this segment, I'm going to talk to you guys. I'm going to show you folks watching along some of the great scalability aspects of Aurora.
Dave, I have a question for you.
Yeah, sure.
Do you
Sure,
have the
DT.
same guy who names all of your products? It's like Serverless and Limitless. What's going on there?
I think, DT, the only thing I can say is less is more.
Okay. Okay.
So, all right.
All right. Well, you have some demos for us then.
Yeah, I have some demos. I'm going to show you, the first thing is I'm going to show you our Aurora Serverless V2 architecture.
Ooh.
So there's some really great things that we launched an Aurora Serverless initial version where we would sort of behind the scenes replace your EC2 instance with bigger ones or smaller ones, causing some interruption as it went up and down. But we said that's not good enough. What we want to do is we actually want to create a special EC2 instance that itself can scale up and down. And then we're going to tie the hypervisor for that EC2 instance into a special customized operating system, into a special customized version of the database engine. We're going to let the whole system move up and down in size while your workload is running. Peter DeSantis did a great deep dive on this in Monday Night Live, reInvent 2023, and you can, if you want to see the real deep guts of the tech, you can go watch Peter's talk. But I'll just show you kind of how it works here. So I'm going to go over here and I'm going to first connect to my database. So data is a serverless database. It's sleeping, and when I connect to it, even though it's sleeping, it's not accumulating any compute. When I connect to it, we are still able to listen to your connection attempt, and we will spin the database up and run. All right. So we're now connected to the database.
And most importantly here, if it's sleeping, that means you're not paying for it, which is one of the value propositions of Aurora 2. You only use what you need, and you only pay for what you use.
Right. You're not paying for any of the compute if the compute is sleeping. Yeah. So one of the things I want to show you within this system, first off, just show you that This is a database that's set up with, this is the data tables, but there's indexes too. It's sort of 30-ish gigabytes of data. And this is, if you're familiar at all with Postgres, and I'm not sure who following along is familiar with the Postgres PG Bench tool, which is a standard Postgres benchmarking tool. We're going to play around with that today. But this is a schema. It just shows like a simple banking application with branches and accounts and stuff like that. So in databases, one of the most important things for performance is your buffer cache. All right, so your buffer cache is how much memory do I have for caching all the data, so I can give quick responses. So I've got a little procedure here that will show me how much buffer cache I have in this database right now. And right now I have a very, very modest 128 megabytes because this database isn't doing anything. So one of the real innovations we did is we actually did surgery on the buffer cache in Postgres and in MySQL to let it resize while the system is running, so you can get bigger and smaller, and we're going to see that in action. So I'm gonna kick off a benchmark run here that's going to run some banking transactions against the system. All right, so it's starting out. It's running 8 different threads that are doing transactions, and it's running, and you can see the throughput happening here.
And it always starts with a vacuum. I mean, our Postgres folks, I'm sure they're in love with vacuuming, aren't they?
Yes, it's very tidy database, very tidy database. All right, so let's take a look at what's happening here while this benchmark is running against this little small system. Okay. So let me go over to CloudWatch. I'm going to show you a CloudWatch graph. So
graphs are good
here, and we're looking at 1 second metrics as this thing's going. We've got a line here of the Aurora serverless database capacity. So this is how much you're actually using in your compute capacity, and we can see that it has scaled up.
And it started at 0, which means that it was basically at nothing.
Yeah, it was at nothing. The green line is the maximum I've had it configured. So I've thrown enough workload at this thing to just hit the max right away. All right. So let's see if we get... This is another chart here. If I refresh that one, this is showing us the number of vCPUs my EC2 instance has that's running, and you see that this number it hadn't even been reporting because it wasn't running. As we've scaled up, we've increased the number of vCPUs dynamically, but we have a very high load. All right, so we're gonna make some changes here, but I do want to show you. Remember, I showed you the buffers of this little 128 megabyte buffer cache.
You did. If it's grown,
so now it's 11 gigabytes.
Oh my God, that was quick.
Yeah. So now we have 11 gigabytes buffer cache. The engine's been running the whole time. There was no reboots, nothing like that. So we want more. So we showed serverless scaling, but we want some more. So I can go to the RDS console. I can just take this cluster. I can modify it.
Okay.
Wow, what's with you folks and modifying it in live production? Grant did the same thing.
We'll do it live. It's not testing if you don't do it in prod. I mean, everybody knows that.
We'll do it live. There we go.
Do it live.
All right. So 16 gig cache. I had 32 gig database. Something. I'll be wild. I'll give it 64 ACUs, and I can actually also dynamically change how much it wants to scale down. So. Let's do that, and I can just while the system is continuing to run. I think you can see in the window there we're still
chugging along.
Yeah,
and those 2 bounds are just so that the system doesn't go wild, right? Like you can basically say, okay, you cannot scale more than the max ACUs.
Yeah, exactly. Like it's budgetary. Right, like so we can think of it like, hey, I had a development system. This is my own development system I was working on, and then now I'm running workload. It's more prod, and so I'm gonna reconfigure it for that. There's other things that we can do here. So it's interesting. I have an informational recommendation: add a read instance to your cluster. All right, why not? So I can just go add a reader. And I can add another serverless instance, or I can add any of our compute instances, even the provisioned, even a 48XL big machine to the same cluster. But I'll just follow the recommendations. And when we add a reader, I'll give it a name.
Yeah, always have to use a name.
Yep. That is going to attach to the same underlying storage. So we're not going to do any copies of storage or anything like that. It just attaches compute to the same storage. You'll notice our throughput's gone up a little bit from where it was.
Yeah.
I'm going to go back over here to our dashboard. Let's refresh this widget here and take a look. And we can see, wow, all right, so we used to be maxed out here, but now we're scaling higher and higher. So our scaling is kicking in. Our number of vCPUs has gone up more, and our load relative to the number of vCPUs has come down.
Right.
So that makes my heart happy.
Yeah, so this is in-place serverless scaling, and by the way, we can go look at our buffer cache now is 16 gigs as we've scaled up, and it will continue to scale up as we go.
That is amazing.
So-
and all of this is happening in place, right? Like you don't have to think about server sizes. I know you talked about EC2 instances a couple of times. I just want to call that out for the folks who are listening in that you're not actually creating any EC2 instances. This is all dynamic. It's all happening under the covers. We are taking care of it for you.
Yeah, yep, absolutely. We are managing it, and it's again the same. It's the same fundamental compute that's running. We will dynamically resize the memory on the host. We will dynamically resize the database. We can even live migrate to other hardware if necessary while the database is
Now,
running.
you said something that tickled my lizard brain. Change the memory. We've gone up. Can we go down?
We sure can, actually. I mean, if I
All right, the old VMware admin in me is
all
very
right.
morbidly
So
curious.
we'll call an audible here. I'll just kill this workload. All right. What we'll do is we're going to move on to the Limitless portion of the
Oh yeah,
report.
we want to see how you scale
Limitless, but we'll come back.
Okay.
Before we wrap up, we'll come back. We'll check the buffer cache size again, and we'll check this CloudWatch
Sounds good.
again, and we'll see how it's going. All right. So let's see. Let's I'm going to kick off something on Limitless database for you.
Okay.
All right. So what I'm going to do is I'm going to run. I got a system running. It's empty, and I am going to put data into it. I'm going to put in 1 billion rows of data.
Oh, you forgot to
billion.
do.
Yes, the 1 billion rows of data.
There you go.
So I'm going to run this script. It's going to create it's going to create a schema behind the scenes. That's going to distribute tables across this sharded system. It's going to load data. It's going to create indexes. It's going to do this stuff. How long do you think it's going to take 1 billion rows to get into this database?
Chat, what do you think? I say maybe about 4 or 5 minutes. Maybe.
Yeah,
I don't know.
That's
Maybe more.
Yeah, I mean 1 billion rows. Well, I'll do a comparison for you.
Okay.
I'm going to run it against Limitless. I'm going to run it against a regular Aurora. So let me kick it off.
Okay.
So this is populating the PG bench data. It's going to create a schema for me. So it's going to run some create tables within Limitless database behind the scenes. That will automatically, without you having to do anything special, do transactional DDL propagation out to all the shards on the system so they're the correct things. And now my client is loading data in the system.
But while it does that, Dave, can you let the folks out there know what Limitless is? I don't think we talked about what Limitless is.
Yeah, and actually we'd be curious in the chat if you guys are familiar with Limitless, if you watched any of the reInvent talks. So Limitless is a managed sharding solution that we built for Aurora Postgres that gives you a serverless endpoint that lets you scale out writes horizontally. We've done scaling up to millions of commits per second. So, Grant was showing you 300,000 writes per second. Limitless, I can show you. I'm not going to do it today, but I can show you millions of writes. I could, but I won't. Millions of writes per second. And one of the cool things that we've done versus like a lot of other Postgres sharding solutions is we built a transactional system for it. That's a distributed transactional management system. So you get the same exact semantics you get in standard Postgres in terms of read committed, durable commits, atomic commits, all that stuff, all the nerdy database things, low-level stuff. You don't have to worry about any of that complexity. We take care of it for you.
And by the way, this is such a huge deal. I don't think that people who have not worked with sharding may realize this, but actually having transactional consistency across multiple shards and treating it as a single database, that is huge. That's an engineering feat.
We're super proud of that. We built on some great technology from EC2 with distributed clocks, and it's really quite cool. So we'll see as this thing wraps up. Well, we just finished loading the billion rows, and now it's going to do a validation, make sure the correct data is there.
You got to validate the data.
Got to make sure that my thing did it correctly. Yeah, I mean, you just,
well, I have a feeling that the naming guy is going to be super happy because, as I understand, Limitless uses serverless.
Limitless is based on serverless. Yeah, so it's just one of the nice things about it because you don't, in a sharded system, you often have to be like, well, which shard? How do I size each shard? Blah, blah, blah. We take care of that. So yeah, so here's your billion rows. So there's the billion accounts, and I summed up. I created this system so that the total amount of balance in these counts, we can call it, maybe it's AWS credits, right? We have 100 billion AWS credits. Now, the other thing that it did while I was just chatting is it created indexes. It created primary keys, unique primary key indexes across all these tables. That in total, we just put 154 gigs of data into the database. We created indexes on that. We created an index that's about 30 gigabytes in size. It did it in 38 seconds. So very nicely parallel. And so let's now take a look at this system and see some of the transactional aspects of it. So I'm going to go over here. We're going to come back to our buffers at the end real quick, but I'm going to go over to use my Limitless system.
Okay.
You know, I kind of get it, right? The scale up needs to be instant. It needs to be quick. But scaling down has to be gradual. You can't just start chucking those pages out, and it can create a performance issue.
Yeah, absolutely. So we'll just go at the end and see how far it scales down before we're done. So we're in Limitless now. And I can select the sum to show you again. A balance from PG. Yeah, see, the live typing is never easy.
Oh. It looks like out in the chat, AM Grabelny is calling out we didn't do the demo dance, so this is what happens. There we go. Now it's just going to work now.
It's the middle of the demo dance. It's still a demo dance. It still counts.
All right. So I'm going to now run a PG Bench workload. So we've got 100 billion credits, right? What I'm going to do is an interesting transaction. This is not the standard PG Bench transaction. This is updated to transfer credits between accounts. So it's going to be a debit credit between accounts. And the really interesting thing is it's going to choose different branches. We're sharded based on branches, by the way. And it will ensure that one account is on one shard, another account is on the other shard. And it's actually going to do these cross-shard transactions. We talked to a lot of Postgres customers that use sharding, and they're like, hey, yeah, all of our queries, we just send to one shard because that's what our technology can support. We would like to do cross-shard queries, but the technology doesn't support it. Well, here we have cross-shard queries and cross-shard writes. So I'm going to kick that off. All right, so we're running, I should have got a little more concurrency there, but we're running about 1,000 a second. All right, we could hit it with more, but we're running 1,000 a second. So we're doing 1,000 per second transfers between shards. Mm-hmm. And now let me go, while those 1,000 per second are running, I'm going to just keep checking how much I have in sum. I'm not adding money into the system or credits into the system, not taking away. I'm just moving them between accounts.
Yeah.
There's transactions that are running.
So technically, that sum shouldn't change.
Some should always be the same. Some should always be the same. And I'll even show you if I actually sum up from those 100. I'm going to scan the billion rows here and do a sum live across a billion rows. It's going to take slightly longer to sum because it's looking at a billion rows. But
and
again,
it's getting it from shards, like shard 1, shard 2, shard 3, and then it's putting it together.
It's going across automatically to all 7 shards that the system has right now. It's doing the sum.
There we go.
And 100 billion. And those shards, again, they're running. Right now, we're doing 800 a second, moving things between. So it's able to still do a consistent view. So that's a quick look at Limitless. Let me, and that aspect of scaling, let's go back to our serverless V2.
Yeah, let's see if we have
we've got about
shrunk our buffer pool.
We've got about a minute left. I'm going to hold you to account on it.
We're back to 11 gig.
Very good.
We had gone up, right?
We
we can just look at our capacity and how it's changed over time. So we we had scaled up. And you remember I reconfigured and I added a much higher maximum and I added a higher minimum. So now we've just scaled down and we're running now back at the minimum I've configured. So it won't scale down further than 11, but I could reconfigure that minimum even back down to 0 and then it will go to sleep. So there you have it. Different dimensions of scalability in our Aurora journey.
Amazing. That was so thoughtful, so insightful. Thank you so much for your time, Dave. We learned a lot. And, very soon we're going to come up for our next segment. So stick around, and we will be back and talk about some MCP.
All right. Thank you, everybody.
Thanks.
Take care. As a old school hardcore database kernel engineer, that's got to be C. It's what I'm most comfortable with. But if anyone came to me and said they wanted to start a new project in C, I would tell them to go away and come back when they want to talk to me about Rust.
I think for me, programming language is more like a tool rather than something a favorite. So I think back in the days, it was mostly Java. I think now we are getting our hands dirty with Rust when we're talking about some more performance-sensitive applications. Yeah.
I'm not a programmer by trade. Mostly I've worked on databases. So, I think in the old days I was a, Perl guy, but, C is obviously a kind of core foundation for databases. So that's what I spend most of my days in now.
Favorite programming language would be C. It's still the best language that was built, and it gives a lot of opportunities for developers to write great code.
All right, well, welcome back, everyone, here where we coming to you live and continue to celebrate the 10-year anniversary of Aurora. I'm your host, Aditya Samant. I'm a Principal Database Specialist Solutions Architect, and I get to work on the star of the show, Amazon Aurora, every day. And with me here to take us on this journey, we have Adrian.
Hey, folks. My name is Adrian San Miguel. I'm a Principal Partner Enterprise Architect here at AWS. I'm working a ton with our service teams. I've had the privilege of working with the Aurora service team probably, I'd say about 80-90% of the time that I've been here, coming up on 10 years. But we're not here to talk about me and the things that I may have built and broken along the way. We're joined today by one of the OGs of the Aurora service team. Jim, would you mind introducing yourself, letting us know what you do and what we're going to be talking about today?
Yeah, I'm Jim Oljenski. A lot of people call me Jimbo, so if you see that around reInvent and other things, just a nickname I picked up in the Postgres community a long time ago. So really a long time Postgres person before I joined AWS, and now I get to work on Aurora pretty much every day, which is really cool.
Exactly. And Jim, we got to talk about the Gen AI stuff, right? We got to talk about LLMs, and we definitely got to talk about MCP.
Yeah. Right.
That's why you're here. So tell us, what is MCP?
MCP, yet another acronym, right? It's like Model Context Protocol. Like, what does that mean?
Who is doing the modeling is my question.
Right. So the modeling part really is how do you tie together your LLMs, that's your model, back down through get the context from agents, right? We have all this really cool information inside of your existing databases, existing applications, and how do you get those LLMs to be able to do that? So in the new agentic workflows of being able to pull everything out, MCP was developed in order to make it easy to create those APIs between them.
Wait a second. Did you say agentic?
I said agentic.
Is
yes.
that a word?
It is now.
Okay.
It is now. Chat, are you using agents or anything in an agentic way? We would love to hear about it.
Yeah. Tell us.
Yeah. So it's one of the things we're going to talk about today is Postgres. We're talking now that Postgres is like a key part of Aurora, right? To me, for those of you that saw Grant and Dave's presentations before, all the cool innovations that had been there before, but to me, one of the key innovations was all of that was built on Postgres and MySQL, right?
Yeah.
So this way, people are interacting with it just like a Postgres or MySQL database, right? So we could kind of have that debate, which one's better, Postgres, MySQL, right? I have my opinion, right? And if you don't agree with me, you're wrong, right? Right? But like for those of you that are MySQL fans, I love you too, right? It does some really cool things, but if you see me at reInvent, I'd love to chat with you about it, right? It's always a fun debate to have those sort of things. Fun debates now that both of them are really clear winners in the database space.
Yeah, for sure they are.
But as we're talking about things like agentic workflows and all these new things, it's like I've been thinking back. It's like Aurora, we're having our 10-year birthday now. Postgres next year is going to have its 40th birthday.
Wow.
Right?
Just a little older.
Yeah. But when you think about Postgres being there at the forefront of all those innovations over the last 4 decades, it's now there just part of everything everything from those original architectures allow you to be able to use the new way that we're hitting this innovation, like huge innovation in the industry now of using LLMs.
Yeah.
Right.
And we love the Postgres community. It's so active and it builds everything and we get to use it.
It is cool, but the original idea of having everything pluggable means this way it could adjust without any re-architecture along the way. So this way, as we're using these new workflows today, like Postgres just works.
It just works.
It does just work, and I understand you may have a bit of a demo for us, Jimbo.
Yeah, I do. So thinking we could start with an existing data model, because everybody does. Nobody's starting with a blank slate. So here we're starting with an IMDb data model, right? That has everybody's movies and everything else that's in there.
I was about to say, did you just say IMDb?
I did.
I do fancy myself a movie buff. I know my wife and kids are watching right now. They can attest to it, much to their chagrin. But continue, please.
But it's an interesting thing to be able to pull data out of there. So a lot of the things that we see with these text to SQL, it works great, be able to do analysis on your stuff. But if you wanted to build an app on top of that, you want it to be able to respond back quickly and give you the same answers all the time, right? So we have this existing there. So if you wanted to build an app in order to be able to cheat at trivia night, right? It's like those are the different things you want to be able to get back the same answer quick and not have it be able to interrogate your schema all the time.
Yeah.
So what we want to do is build an app on top of that, but use the LLMs and use MCP in order to be able to generate the right SQL of what we want to do.
Hey,
well, before you start your demo, is it true that LLMs and MCPs actually allow you to talk to your database if you're talking to a person?
Yeah, you can, right? If you want to be able to do that. It's like, I don't know how some of that will translate with some of the accents we got going on here and how to get through, especially as, some of the different nuances in database technology, but sure, right? But I'd much rather abstract that out and not let it talk directly to the database without going through something that I built and control and vetted, right? So when I have a production database, running ad hoc SQL, I don't want a human or an LLM doing it. I want to be able to look at SQL that I've vetted already.
All right.
Question for you from the chat, Jimbo. What is your favorite movie? Asked Gladiator Q80.
My cousin Vinny.
Yes, it is an American household classic. It is an institution in my home. We watch it every Thanksgiving and Christmas.
It is every time it's on. I can't stop but watch it.
Yes.
Right. So we're going to use Q here in order to be able to start what we're doing. And I have a couple MCP servers already loaded in, right? Q is an MCP client, and you could do that. So we have an existing one here that's the Aurora MCP server.
The all-knowing Q. Did you get that reference?
The Q, right? And then we have the sample weather one that comes from the getting started of the GitHub for Model Context Protocol that's up there. It's just a nice sample in order to get the weather for whatever city you want to be in, right? But it shows that both of them could load in without any special things, right? But first we need to say, well, what tables can I query, right? So you guys are going to have to put up a little bit with my bad typing, right? It's like
I know the Q doesn't care.
It doesn't care.
Q doesn't care, but it does mind if you don't do the demo dance.
Right.
Protocol.
It doesn't care, but I come from a generation that puts punctuation on text messages. Yeah. Right. So it's like I have problems with having typos. Right. So this is all the tables that we just saw in pSQL. So let's create an MCP server that's going to return all the characters for a given movie. Okay. So let's start with that query. You go write a query that returns all of the characters. There's a typo for a given movie.
Well, while we write that, I want to ask the audience: have you used an MCP server yet? Yeah. Let us know if you have.
What have you built?
Right.
What have you built?
So now it's going to call a couple tools here to get the table definitions.
Okay.
Right.
Yeah. And I see that you don't trust your MCP because every time you keep saying yes.
For the queries I do, but when it's getting the table schemas, that's a vetted query that I'm cool with. Yeah. Right. Right. So it look at this. It did produce this query pretty quickly right here. Mm-hmm. Right. Do you want to run it right with the? Sure, I'll try to run that. So it's going to do it for the movie The Godfather.
Okay.
Right. You want to see if it does that? Cool.
And while this is cooking, curious on why you chose The Godfather, aside from it being a classic and probably the highest rated movie still on IMDb.
It really is a classic, right? That and partly because there's not too many different options there. So as the query is running, there's not going to be too many results coming back, right? So it's trying a couple iterations. Now it's trying to narrow it down with the start year of 1972.
Okay.
Right. But, as you can see, it's doing the testing and be able to figure it out to make sure it's getting back the right results for that. If this was doing text to SQL and you had your app that's going as it's all running in the background, you're going to close the app, go do something else.
You're going to force close it and move on.
Right. So this is why we want to build this ahead of time. Right. So return back to all the right results. Right. But really, here's the query for 1972, right? When you look back at some of these, we really wanted to use this original query way back here with the full text search, right? Yeah. Because everybody else types as bad as I do, right? Or if we're trying to do the text to SQL, right? Or the talk to SQL, even worse of what's coming through.
Do that fuzzy matching.
Right, right. So when you look back at how was it able to pull that up so quick, that's one of the tricks there that's in Postgres. So if you look at the description of the title tables that's here, right, has everything on there. But if you scroll all the way over here, they have these descriptions. These are all the descriptions from the IMDb catalog of what each of these fields are. But I created this title TSV table and be able to put in there how to actually use this column.
So that's going into the context of the MCP.
Exactly. So when it's trying to get the table definition, right down to where it even pulled the Godfather as a sample. One of the cool things about Postgres of being able to put comments on your tables and on your columns, it gives you that context of being able to use it in the LLMs directly, because it's not like you're telling a human over a cue ball, like what's in this column. You have to be able to tell the LLM somehow, right? So getting back here, like use the full text search query, okay? But the reason it didn't use that, because it couldn't narrow it down to one title. So now we have to figure out how do we get one title.
Okay.
Show the movie with probably the most popular one we want to do. So we want to join to the ratings table.
Let's do it.
The most votes in the ratings table, and these typos are really getting to me.
Oh, don't worry about it. It's all good.
It's all good.
Right. Q doesn't mind.
When multiple titles match the same name. And let's see how that
is
does it.
very specific.
By the way, audience, the chat. Did you guys know that Q is a free tool that you get to use without actually having to pay any licensing fee? Try it.
So now it's thinking a hard time, because it's I gave it a little bit more specific there, right? Yeah. So now it's going to be able to go check out that ratings table in order to be able to get that, right? So now it's going to do the full text query and go back and be able to, oh, look at that. There we go. Let's see how that goes.
All right.
Run that.
And it's fractions of seconds that it's taking to go out and run and figure this out.
It likes to say perfect quite a bit.
Yeah, it does. It thinks highly of itself, but
right. Don't we all?
Right. But when you look at it, right, it actually did get it out. So those of you that are like following on a mobile device, this is where you kind of want to pinch in and zoom and take a look at this query, right? It's like when you look at it, here it's using the full text search that we kind of told it about, but it's using a CTE along the way.
It's showing off, isn't it?
It is showing off a little bit, right? In order to be able to get that, right? So we're able to kind of get down to that query. So this way it's using the popularity of the movie to return back the intent of what you're looking for, right? So that looks pretty good, right? So let's like write that query to a file, query.sql, right? So let's save that, because now we want to put that into our MCP server, right? So that's good enough. It ran pretty quickly, gives us what we want, right? So now it's thinking a while in order to be able to write out a file. It should be pretty quick, but here we go. We'll do that one again, not trusting it, right? This is my development environment. I want to be able to make sure things are doing the right thing.
I wonder how long it's going to take before we say something like, I'm too tired to tell you what to do. Just guess what it is that I want you to do.
Right?
That's vibe coding to the next level.
Right? So now I'm compacting down the context a little bit, because we don't need to keep everything. We just need to keep the results a little bit. Mm-hmm. So let's do, right, an MCP server that has a tool called, let's call it get movie characters. Now we're going to be specific here. Use. So here's that weather MCP server. I want to use this as a template, right? So this way it knows what it should look like.
Add it to the context.
Yep. Mm-hmm. So the tool.
Well, while you go through and clock this out, it makes me think, if I was presented with this problem and asked, hey, can you go generate this query, and each of these individual dimensions, that's a different Google search, that's flag switching, and that's trial and error and experimentation. That's kind of absolved here in the sense that it not only is the service able to help you get there along the way, it's going to be pretty suggestive, and to your point earlier, when building out the CTE, showing off.
It did, right? It's not the first way I'd solve the problem, but it's a good way to solve the problem.
But it is a nice way.
It is, right? Right. So now we're telling it to use the SQL as a template, and let's see what it thinks here. So we're giving it the query that we were able to generate, as well as the template for the weather there of how to create the MCP server that's there, right? So it's kind of join the two together, and let's see if it figures out how to even connect to a Postgres database, right? So this is what it kind of did, right? It's not a bad job here. Like so when you think about it here, it's pulling things out of a config file in order to be able to connect to a database, right? And here it's writing all the code to even format the character results as it's coming out.
It's writing pretty formatted code too. Like I don't like code like that.
So this is the real trick here for MCP servers. It's this comment here. This goes back to the MCP client, so this way it knows what this thing is supposed to do.
You mean comments help you figure things out?
Comments tell you.
Imagine that.
It's like you're talking to a human.
That's like your job, isn't it, to comment on everything?
A little bit.
Right. And here's that cool query that's there. So it ran it there, being able to connect to the database.
I bet it's going to say perfect now.
It probably
Hopefully it does. Stupendous. It's just going to throw a curveball at you.
So now it's going to give us our requirements, right? And my guess is usually it's going to give us a cool little README on how to use this thing.
That would be nice, because having to go back and actually clack together a README with relevant examples and have to go backtrack and update it as you go, that is a bore.
Yeah.
Now I'm thinking about how badly I've neglected my Git repository. Thanks for shaving me. I appreciate it. Thanks, Jimbo.
So here's a config file to be able to put things in there, right? So this way you have a way to be able to set your connection information along the way, right? So here in the span of what we have about 15 or so minutes, we took everything, created an MCP server that we can now use to run that query. That's a pretty complex query. It took a bunch of iterations in order to be able to get there, right? Same as a human would go do it. So if I went and had a new schema I never looked at before, I'd have to be able to query it a few times to see what the data means, be able to construct what all the queries are, and then finally be able to go ahead and like construct that query based off of knowledge that I didn't have anything about. So it was able to make that query very, very fast. But the key of not having the LLM create the production, it creates the production code, but not actually run the production code for you, right? So this way we could go through a code review for that MCP server. We make sure it does what we want. It's hitting all the indexes the right way. Because even though we have all the cool scalability stuff that Dave mentioned before, being able to scale up and scale down, we want to scale up because we just hit like the front page on like Hackers News, not because we have a bad query. Right? Like you don't want to do it for like the bad situations. We want to do it for the good situations of just more traffic and more business of what you're getting.
That's quite amazing that what we're able to do here live in under 15 minutes. That is that's quite phenomenal.
It is. And as we're wrapping up to the close of the session, Jimbo, got to say, what are you looking forward to next? Is there any particular call to action or a bit of homework that you would have audience out there go and do and discover?
Yeah, I think part of it is MCP is still super new. Right, so the spec only came out about like less than a year ago, last November, right? So it's brand new to everybody, and it's evolving really, really quickly, right? So as this becomes more and more mainstream, like, are we going to be building MCP servers 5 years from now? I don't know, but it's going to be something like what MCP is now, of that self-discoverability of what their agents could do and going back there. So understanding that, but also just going back and doing good hygiene on your schemas, putting those comments in there, it made everything a lot faster in order to be able to get the right context of what's in your database.
Help MCP help you.
Exactly. So you can either type a whole bunch of prompts and you could look at my really bad typing, right? Or you could just put it as comments inside your database. So not only the LLMs, but the humans actually look at it to do that. So one of the cool things about Postgres, it just makes it easy to do that, right? So that's why when we think back of Postgres over the last few decades, Aurora over the last decade using Postgres, like that's why it's ready for the next innovation that's coming along the way. Postgres has all the stuff built in already. So this way we can just leverage it and start using it.
Awesome. Jimbo, thank you so much for your time. Really appreciate you hanging out with us today. Real quick, folks, don't forget, we do have the survey. The first 3,000 viewers are going to get a $20 AWS credit when you respond and let us know how it went, what you like, what you'd like to see more of, and we will absolutely iterate on that for you. But I understand we got a little bit of a treat coming up, don't we, Aditya?
Yeah, we actually have a founder session. So all the OGs, all the founders, they're going to tell you some behind-the-scenes secrets. So we have that segment coming up. Take a look, stick around, and we will be back after that segment.
Aurora Founders Roundtable. Now we have a bit of a treat for you today. We have the Aurora founders, the OGs, if you will, and they are going to pull the curtain a little bit back, and they're going to give us the inception of Aurora, some cool stories, and we're going to learn about how Aurora came to be. All right, Swami, well, let's start with you. So before Aurora, there was RDS.
Yeah.
Right? And RDS was and is still very popular. Our customers love it. Why did we want to build Aurora? What was the motivation?
There's a lot to that story. If I were to answer it, I'd say first it's because, I don't know, Grant and I were having a beer in Elysian on Friday at 4 p.m. But that's probably not the answer you're looking for. I would probably say I mean, Aurora had a lot of actually initial founders, not just Grant and Jan or Raman who's here, but Raju and few of us got together and we were forming database strategy. One of the core things, I mean, we actually were building Dynamo because we actually wanted to build the unlimited scale, always actually on database that was DynamoDB, but then we asked our question saying like, hey, originally SQL databases were built for like running in a server with attached storage. What if you had to reimagine database and what would that look like? So this kind of unconstrained thinking led to saying like, we need to reinvent databases for the cloud, the SQL databases. And this led to what became Aurora. And that was the core reason, because traditional RDS still was like, hey, you're going to run the engine like Postgres or MySQL on an EC2 with underlying storage, and you're going to run it the way it is. But Aurora was born out of this unconstrained thinking on the compute and the storage and the I/O and the ability to do like on-demand snapshots. There are so many innovations we can unpack, but all of it was started with a very one simple question. If you were to reinvent databases for the cloud, what would that be? And that led to Aurora.
Yeah. And like we said at reInvent, right? Aurora, the new dawn, right? And it was pretty innovative at the time, still is, but we basically built this compute and storage and the distributed storage. But I think there was a specifically big bet we made, which was the compatibility with open source, right? We could have just made our own database engine. We didn't. What was the motivation for that, Grant?
So, I mean, originally, as Swami said, we really had kind of an open book when we looked at this, because we were just like, what can we do, right? And so originally, actually, we're looking at building things, a lot of different things. And really what you see as Aurora today was kind of probably about the third iteration, right, on that. But part of that, cycling of going through that was really thinking about how do we serve customers best. And even though with Dynamo, where we've, kind of pioneered something very specific that had a different interface, but it was for a different purpose. But for a relational database, we wanted something that customers could really adopt and use. And what we saw was that if we went and used open source and made it open source compatible, then we're going to have something that was going to have much more leverage for the customers, much easier to pick up, easier to use and integrate. Because one of the big things is you can make the next generation database, but if customers have trouble adopting it, it doesn't really do anyone any good. And so I also felt that like the open source community had a lot to offer, because you're basically partnering with a group of people who are trying to innovate as well. And so you get that combined effort of both us innovating kind of from a cloud perspective with these groups innovating on the actual engine software. So that combination really allows you to have a much better service for the customers in the end.
Yeah, makes sense. And we're gonna have a little bit of fun. We wanna pull that curtain back a little bit. Want to know about what happened back in the day. So we have lots of code names, is what I understand. Yeah. And we have heard about that, like Grover, and there's Manfred and Oscar. And I hear that there's a little children's show that has had a lot of influence on that. What's the story there?
Yeah, so actually in the early days of AWS, RDS, actually, the code name for RDS was actually Relational Database Service, because we didn't actually have a code name back then. But some of the other services actually had chosen
Well, hello there. What do we have here? Who is this?
This is again another
Kermit the Frog.
Yeah, which is one of the code names for one of the services or one of the features that we built. But both Dynamo and Elasticache had both chosen Sesame Street characters as code names, and we had at the same time picked Oscar as our one for Aurora. And that was because it was partly my pitch along with Swami and folks, and I was a bit grouchy back then, as Swami could probably attest. So Oscar the Grouch kind of fit with that. And then when we got the storage going, I was like, we were sitting there saying, well, we really need a code name for the storage. And I said, well, Grover is Oscar's best friend, so obviously it needs to be Grover, right? And that kind of continued for a while. We've off and on used different names. Manfred is another one where we had to kind of go further because the Postgres community had used every elephant-themed name thing gone. So we had to go
animals, as they're called.
Yeah, exactly. So
I've heard people say, "Do you know your animal?" I'm like, what does that mean? Of course, they're talking about Postgres.
Yeah. So, yeah.
I know. We stopped actually. At that time, I didn't even have kids, so I didn't know the Sesame Street character, and I grew up in India. So I was like, why are they so obsessed with all these things? So I had to really go see a couple of Sesame Street shows to even understand all this etymology, because Dynamo was called Big Bird, Elasticache was called, I think, Elmo, and Oscar, Grover, and then it kept going. At some point, I said, the point of code names is to keep certain projects secretive. If everybody actually thinks one more Sesame Street character, then they will know, okay, it's a database team actually building one more thing. So we stopped naming any code name to be Sesame Street based. But it was actually a fun time.
Yeah. Yeah, and it leads to fun things like, one of your colleagues dressing up in a in a nice outfit to deliver a wonderful cake, right?
Yeah. Well, so, at AWS, we take pride into this builder culture, right? We are all innovators. What are some of these early innovations that we did, and what have you taken with you from those early innovations? Sharman, I'd love to hear from you.
Yeah. I mean, I think one of the most important learning through my journey in Aurora, in general, AWS, has been like customer first mindset. I think that is really, really important, especially in a field like database services. I mean, database are one of the more complex software systems that has been built, and it becomes easy to get caught away with technological innovations. Or I want to build this cool thing; it will give me this output. And what really matters is that output helping a customer solve its pain point? If not, that's probably not the best investment. So it's really important to also take risk, but failing fast and making sure you are getting to the customers. And I think the other learning I would say is really thinking about scale. I think a lot of the things we could have done better was like if we were putting really this scale, which I think nobody really imagined at that point in time, really putting that in perspective and designing for that would have help us even move more fast in the whole journey. So I think that was just overwhelming overall.
And I mean, that's the funny thing is that we did actually plan for scale, right? But I don't think we planned for the scale that ended up happening, right? Like that's the amazing thing is you think, well, it's databases. How many databases could people want? And as it turns out, a lot.
Yeah. And how the scale changes the whole equation. Like it just changes how you build software, how you deploy software, how your communication, information flow in this organization. How do you think about scalable process? It just changes for Aurora every year now. We have to keep up, otherwise we are just left behind the curve. It's really important.
And the one thing to remember is some of this will sound obvious right now in retrospect, but this was like early days of cloud, probably 5 years into AWS or maybe something like that. And the scaling patterns of cloud and adoption patterns of cloud was exploding, kind of like where the AI era is right now. And so we were literally inventing what is going to be the net new way of building systems and software at every layer of the stack. And Aurora was one such amazing example there. And it's fascinating to see that trajectory hasn't changed because of this kind of growth.
Yeah, I think Aurora was probably one of the services which were built completely in the cloud on foundational AWS services like EC2 and S3 and some usage of EBS. And we had to build a bunch of systems, even to deploy our software in this complex stack, we had to build our own deployment story. We had to build our operational console story, like a lot of dependencies or softwares which were not existent 10 years back in AWS. We had
and I'm sure you have a lot of those stories. Like you were just a young engineer when this started, and now you're managing an engineering team. So any cool stories there?
Well, I think I would say those are cool at that point in time, not so cool now. Even like talking about these thing, like whenever we build some, like let's say a bespoke solution which was needed at that point in time, we are not really in that business. We are a database service. And it's just we cannot keep up with the industry or with the other innovations which are happening in that domain. Like even if we talk about deployments, right? We built our own. Now we have to keep up with all the advancements which are actually happening in, like, let's say, builder tools, which are being leveraged by all other teams at Amazon. And that's where I go back to the customer obsession part. It's always cool to build new stuff, but it's really important to think ahead and think long term before we just take the cool factor into practice.
Yeah. That makes sense. And Jan, as we innovate, there are a lot of successes, but innovation is not without failures, right? How about some stories about what we were trying to build something, it didn't work out, there were some failures, and what did we learn from that? How did we adopt?
Yeah, for sure. I mean, can't really ever say that we only succeed. Early on, we heard from our customers that they want fully scalable solution that would offer multi-writer. And we built this from them. We built it first on MySQL 5.7, retaining full compatibility with it. What we have learned that we just can't carry on with that. Solution was too complex, and it actually didn't satisfy our customers enough. That was the reason we decided to build DSQL. We decided that some of the requirements require compromises, require trade-offs, and we decided to build truly multi-writer capability within region or cross regions, but take back on our fully open source compatible requirements.
Right, and now DSQL not only does in-region, but also cross-region multi-writer.
Yes. That's where we decided to innovate. We decided to take this innovative log-first approach that would let us not just deliver multi-region solution, but deliver performant multi-region solution. That's at the end of the day what the main factor that makes database successful, performant.
But I would say, like, one of the interesting things is that, with these trade-offs, because there are trade-offs with all these technologies, is we like to offer, like, that was one of the very first things when we started RDS and then into Aurora, was really about giving customers, options for these trade-offs, because different engines provide different capabilities, whether it's MySQL or Postgres or DSQL. And, these trade-offs of, let's say, Aurora, Postgres, global database, if you want something that has low latency writes, then that's a great solution for you. If you need something where you have synchronous writes across region, we have DSQL. So, it does add a little bit of complexity to the choices, but in the end, if you're a business and you need some specific, capabilities with very particular trade-offs, we're trying to make sure we're doing that. So it's not like we've picked one thing and said, well, that's going to solve all the problems, because we've learned over time, again, with the multi-writer example, that there are these trade-offs, but it also means that you can't just have one solution to go with.
And also meeting customers where they are. I mean, we shipped Aurora MySQL first, and then we discovered customers really want Postgres, and we delivered Postgres as well. And doesn't mean we abandoned MySQL because of that. No, we continue to move full front on both engines. The same with DSQL. Adding a third engine doesn't mean we're going to pay less attention to the first two. We know that we want to deliver on all three.
Absolutely. And Aurora started as a single engine. It's now a portfolio of services, right? So yes, there are trade-offs, but there are different trade-offs for different workloads, which is why customers love it still. So it kind of brings us to this sort of like conclusion, right? Like we are now celebrating the 10-year anniversary, but we're not done innovating, not nearly done innovating, right? So this is for all of you, right? Like how do you see the future? What sort of innovation is coming? Of course, we may not be able to talk about individual features here, but what's that vision like?
Maybe I will start.
Yeah.
I will start. So why Aurora is successful. I think our attention to fundamentals, it's probably number one factor. So a lot of our innovation is coming not on the feature side. They are coming for making service more and more available in the face of failures, more and more available even for regional availability. So a lot of innovation are not necessarily seen by customers, but make their application perform better, make more and more application be possible on Aurora. Let's talk about agentic applications. We now seeing explosion of multiple application, explosion of instance of application. We should expect 3, maybe 4 order of magnitude more instances. How do we handle that? That's the big question we are working on.
So that's like sort of manageability. I mean, when we started with something like RDS, it was very common for, a person to have to manage every piece of their database, right? And we've, slowly made that easier and easier. But so the number of databases has actually grown a lot in most companies. Like I remember when we made these things easier inside of Amazon, we saw like almost an order of magnitude growth in the number of databases. But now what we're seeing is, like, as Jan was saying, it's going, just ballistic. And to do that, that means customers, when you used to have one DBA manage one database, now someone might be managing 100. Now they're going to need to manage 10,000 or 1,000,000 databases, right? So that can't be done with just the, standard ways of managing. So we need to change the model of how we do manageability. And that means everything has to get simpler, easier, faster.
Yeah, I agree. I'm happy to go in the end if you want to add.
Yeah, I mean, I think what to Jan's point, like fundamentals for a database service will probably never change, right? You need more performance. You need it to be available all the time. You need it to be cheaper. And I think like when we are having this data at scale, it's very different than when you're just starting. Like you don't have much data to make decisions, optimize your stuff. But when you are at that scale, this is a gold mine of actual data, which allows you to tune this whole thing, making it more like the better customer experience, whether it's cheaper, whether it's more performance, right? This is just like standard, like how do we innovate at scale outside, like more, you can say more features and stuff. This is just on fundamentals. I think that's what customers need really to work with databases all the time.
I love what everything that they said. I'll typically, when I get asked question about like in future what's going to change, I always answer it in 2 ways. The first one is like it's super important to recognize what's not going to change, and then you should talk about what's going to change. And what's not going to change is very similar to what Raman and Grant and Jan said. People are always wanting to have the best-in-class security, best-in-class durability, best-in-class availability, best-in-class performance. These are like the bread and butter. I would almost call it like air, water, and food, and that priority. I don't know what is more than food. After that, beer. But that actually is always going to be like the core thing you'll hit. But what's changing in the world right now is we as the entire world, like cloud changed IT. And it changed databases fundamentally, led to technologies like Aurora, where the role of a DBA changed in a big way, as Grant called out. But now in the future, especially in an agentic AI world, where agents are actually not just creating databases, but they are actually querying databases, and then they are moving data to analyze, and then they are making a bunch of these decisions and so forth. Who interacts with database no longer need not be a human developer writing static code. These agents are now generating code literally on the fly based on a question a human or other agents might ask. So you're already starting to. So what does this all mean for something like Aurora? And I won't give away any of the major launches they have because I'm not even in their day-to-day meetings. So otherwise I will be hallucinating, and it's not a good thing, like an LLM does. But actually, if you look in the recent past, and it's a pretty good indicator, Aurora was, this is when I was managing Aurora, they launched PGVector, and it was one of the most performant PGVector in the industry as part of Aurora. And that enabled a whole new slew of like RAG-based apps where if you're PGVector is co-resident with your relational data, suddenly the joint hybrid querying, all these things become remarkably easy. That was like, they did it instantly. The next thing, I mean, now you're seeing is more and more, you saw already entire AWS is embracing like MCP with our MCP knowledge server and various others so that agents can enable, and Aurora will think through more and more across these things directionally. So, but also, and let alone what does it mean in a new agentic world where you not only create tens of thousands of databases dynamically, but how do you manage it is a very interesting question, because we as humans then need to really start changing our mental radius on actually how do you think about like managing, going from what used to be one DBA managing like 1 to 2 big giant databases to now they are like probably 10 to 20 to now agents managing tens of thousands of databases. How do you you're going to get into a whole different slew of game. And in case anyone is noting down, I'm not revealing any roadmap because I'm not even involved in those things, but this is how directionally, I mean, these are the things where the industry is going. And you can imagine Aurora being the center of everything. We want to enable all these amazing capabilities as well.
Thank you so much for your time. I hope everybody learned something, and well, thank you so much.
Thanks for having us.
Well, hello everyone, and welcome. So we continue the Aurora 10-year anniversary celebration here. And in this segment, we are going to talk about a problem that is as old as databases, which is to make databases available in more than one place, right? Potentially even globally available. So to talk about this specific problem and how we solve it with Aurora, we have our very special, globally renowned guest, Cheyenne. Of course, Cheyenne needs no introduction, but for the few who are out there who don't know you, Cheyenne, why don't you introduce yourself?
Absolutely. Thank you, Aditya, for the super kind words. Hi, folks. My name is Cheyenne Sanyal. I'm a principal Aurora specialist SA, and I've been working here at AWS since 2017. And over the past several years, I've seen a lot of customers use and leverage a lot of the features that Amazon Aurora provides today. And let me tell you, Aurora has achieved something I never could. Being in 10 places at once and keeping everyone happy. I could never do that.
Well, that would be unnatural for you, Cheyenne, but perfectly natural for Aurora.
I mean, it can actually, if you look at the performance of it, it can replicate data faster than your, I don't know if you prefer Starbucks. Your Starbucks order is a venti ice latte, light ice, non-fat oat milk. By the time you say that, it can actually replicate data for you. Wow. So that's how amazing it is, and we are going to dive deep into it today.
That is excellent. So, Cheyenne, I know that you have some fantastic demos prepared, and we want to get to that. But before we get to all of that, tell folks who are listening in, why did we even build this thing? Like, what is the problem that we're trying to solve? And, we'll eventually get to how we're solving it. But first of all, we want to know, like, what problem are we solving?
Absolutely. So if I'm allowed to just bring up my screen real quick here for a little bit. And so just to kick things off, Amazon Aurora, first and foremost, is our flagship relational database. Right. So it comes in two of the most popular open source flavors that we offer today, MySQL and Postgres. And Amazon Aurora Global Database actually builds upon that core Amazon Aurora architecture. And the way we do this is we are using some storage-based physical replication that actually allows us to span multiple regions globally. And where the most recent announcement that we actually did, if you've been following the journey on global database specifically, is we started supporting up to 10 secondary regions for those global replications.
Yeah, we doubled it, right? It used to be 5, now it's 10.
We used to, exactly. So what that means is previously, you used to, with any Aurora cluster, you used to have up to 15 read-only replicas. Now, double that, we actually have 15 for each secondary region, plus the primary, for a total of over 165 read-only replicas. Imagine that scale.
That's a
right?
massive scale, right? Like 160 across the globe,
Across
and
the
that's in a
globe.
single cluster, right?
That's in a single Aurora database cluster.
That's amazing.
So that's number one. Number two is due to the storage level architecture replication, which is physical, we are actually able to get over a lot of the traditional logical replication challenges and are able to replicate data in typically in less than 1 second. We'll actually get into a lot of those details in some nice little demos that we have planned today. But the performance actually comes from the storage level replication that we do with global databases.
Now, Shayan, you talked about logical and physical. Can you give us a quick understanding of what that means?
Absolutely. So logical replication is where a lot of our typical database engines, what they do is we do write a lot, right? Anytime you're reading or writing data from your database to your database, these changes are actually captured in a so-called transactional log. Now, different databases have different ways of calling it. Some call it the write-ahead log, which is what Postgres does today. We also call it the redo log, which is what is supported in traditional databases such as Oracle SQL Server.
Right.
There's also bin log, which is now in MySQL. So capturing these changes and playing it over to a completely different continent, imagine across the ocean, across the world, takes time. And due to the asynchronous nature of it, it's not actually physical replication. We are actually just capturing these changes in one place, replicating this over the wire across the ocean to a different continent altogether. That actually takes a lot of time. That takes a lot of effort. That takes a lot of resources to get those changes across in another region. And so those are the challenges that we are stuck with logical replication. It actually takes a lot of time. And there's also this increasing notion of replications lag that kind of goes on and on and on, because you have a mission critical database, you're constantly writing to it in the primary region. You're not going to slow your business down just for the secondary region to catch up. So there's this ever growing tension and friction on the need to catch up to what my existing state in my primary and the secondary is. So now and that actually falls in like a far end of the quadrant. If we look at like a graph of how quick or how soon you can actually replicate data to another region. Now, if we go closer and closer, basically now we come down to physical replication in that quadrant, which actually gives us way better performance, way better replication lag, because of the fact that we are actually taking, it's an all or nothing notion. We are taking all the data pages from your storage, using purpose-built special proprietary hardware to actually ship everything at once to the secondary region across the ocean. And because we are using the special sort of secret sauce, these are special replication servers, we are able to get to typically a less than 1 second replica lag in the secondary region.
That is fantastic. When you say 1 second, that's across the globe, right?
That's across the globe.
You can have one leg in, let's say, the US, and then another one in, let's say, the European Union. So that's fantastic. All right. So tell us more. How did we build this thing? So sounds like physical replication is kind of the foundation of this global database. What else?
Yeah, absolutely. So there were a lot of customer pain points, right? So if we look at like the history, the sort of just take a rewind of the past 10 years, customers kept asking us the same thing, but in different ways. They asked us, like, we need our relational database everywhere instantly without the complexity. Some customers wanted cross-region disaster recovery that actually works. Others needed fast local reads globally without eventually consistent headaches. And I'm sure you'll relate to it. I relate to it. We've been DBAs. We've seen these firsthand in our journeys where there are so many contracts that you actually have to set up with your vendors to do this cross-region, multi-region setup. And it's a massive headache, right? The planning the data center, planning reservations of guaranteed compute capacity, etc. It's just a disaster. And many other customers actually faced other challenges. There were things like cross-region migrations that meant you have to spend a weekend completely down for your business. And everyone wanted everything without actually hiring a global DBA team to manage all these things or rewriting their applications.
Yeah, and I think to that point, we also just recently released global endpoints. Right now, you can just have a single endpoint that just follows everywhere. That's quite fantastic too.
Yeah, I mean, thousands and thousands of customers have sort of brought it up. We want to fail over or we want to switch over. We basically want to do this region rotation for our applications, maybe to test some disaster recovery drills, maybe to prove to our auditors that our same application stack can actually work the same way functionally and is equally or even better performant in the other region. And for that reason, they don't want to make any application changes, right? Historically, what used to happen was we used to have these regional endpoints, and which is actually very true of a lot of our other services, where we are connecting to a regional endpoint based on that specific region. And those applications, what happens is when you do something like a region rotation, which we call switchover, which is a planned event, or a failover, which is an unplanned event, you would typically after this event, you would get a new endpoint, which now the application has to modify and update its DNS to point to that database endpoint, new endpoint in that specific
lot of
region.
work. Lot
of work increases your RTO, increases your RPO. Not a good story to tell to your boss. So we wanted to avoid all of that.
And it's a Brillo experience too, right? Like, I mean, there's a human intervention, so something might go wrong. I mean, imagine changing a DNS to a completely unrelated database, and now you're writing to a database that you never intended to.
Exactly.
I'm sure everybody wants to see demos, right? This is enough talk. Let's get to demos. Show us how it works.
Absolutely. So I'm going to bring up my screen with the console now, and hopefully thumbs up if you can see it.
Yeah. 10-year anniversary, 10 reads.
Yes.
Perfect.
Awesome. So this is the AWS console. This is pretty typical of our RDS users, RDS customers. Again, thank you for being a customer for the last 10 years, if you are.
Thank you.
So this is our RDS console. And what we have here, something special, of course, is the 10 regions. So now we actually support up to 10 secondary regions in your global database cluster. And this is how this cluster topology actually looks like. Now, if you look at it very closely, currently my primary cluster is actually US East 1. My secondary, all of these 9 secondary regions are a whole lot of mix and match. You'll notice maybe I'm a business. I probably am doing really well in the US today. But then I want to sort of also just dabble around different markets, different geographies. I want to test my product in some different areas. Maybe I'm a restaurant operator and I want to open a few different regional restaurants, get a hint of how things operate there. And what this does is actually demonstrate that situation where a lot of my new users are actually coming up in Tokyo, Japan. Some of my analytics and reporting is actually running in Mumbai, for example. I have Singapore, Sydney, so on and so forth. But my primary business is again US. And what we actually have here, Aurora, what also provides, and we've done this innovation again based on a lot of feedback from our customers, you can mix and match the instance classes and the configurations, etc., that you have in your cluster. Note again that this is one global database cluster. But then my primary is actually using my latest generation Graviton 4 instances here, for example.
Yeah.
My Tokyo region, which is fairly new, I've seen some spiky workloads coming up occasionally during the night. It's actually pretty idle. So what I need is something that can save me cost. It doesn't run all the time. It can scale to 0 automatically. So I have a serverless B2 instance here with a min ACU setting of 0. Similarly, I have another Asia Pacific region, Singapore, with a serverless cluster. I have my other primary sort of another business operations that I run from the Pacific Northwest, so US West, is also the latest state-of-the-art Graviton 4 instances. But then note that I mentioned I have my analytics team actually doing some reporting, etc. in Mumbai. And for that reason, I actually have a completely different instance type. Now, this is where Aurora also introduced the optimized reads feature for our standard provisioned as well as global databases. And now what that does is it gives you sort of a photographic memory for your cache. Anytime you have data that exceeds, imagine like reporting workloads, you're running massive of these reporting queries and constantly. Your next person in your team is actually asking repeatedly for those queries. So what happens is this style of an instance class, which is a dense compute family, is able to cache a lot of that repeat report request within the compute instance itself. And what that means is lower network I/O to the disk. What that means is faster reads of those reports, faster retrievals, and happy users at the end of the day.
Yeah. So you use exactly the type of instance, type, and class that you need, and you can just have a mixed cluster, regardless of how many readers and writers you have. Well, just a single writer, but multiple readers.
Exactly. So this is the beauty of it. The way you convert a single region cluster to, let's say, like a multi-region cluster is again very straightforward. For those who are not familiar, this is already converted to a global. But then what you would do is just go to your regional cluster and click on the actions and just add a region. That's
So
all
simple.
you need to do. Just a couple of clicks and we take care of the heavy lift for you. We'll build up the global cluster topology. We'll add the secondary regions, etc. Of course, you will specify some specific settings around parameter groups, etc. But the heavy lift of establishing that replication, designating those primary and secondary roles, etc., is all taken care of for you. So that's the beauty of global databases. Now what I'm going to do is start actually getting into a little bit of the demo. And what I've done here is actually written a couple of Python scripts. There's a couple of automations that I've done. And what we're going to do, just because we are celebrating the 10th anniversary, I've captured Aurora's greatest hits in a couple of tables. And we're going to just go over this whole simulation. So this demo is called Around the World in 10 Seconds. So what we are going to do is actually start seeing by way of different tests. What I did here was actually, let me maximize this a little bit. I inserted a record in my first test, and I just inserted it into a table. And you'll notice that within less than a second, this is the lag in milliseconds, I was able to replicate it to all of my secondary regions.
So even the highest lag is less than a second. That is fantastic.
The highest is actually 847, which is in Mumbai, which is the farthest apart right now.
Right.
Note that my primary is again US East 1. We are in Northern Virginia. Now let's go on to demo 2, which is where we do a little bit of celebration, so-called celebration. So if you look at the historical timeline of how we have evolved, what are the various milestones, some key findings are here. And folks who are watching, do pay attention to the years because there's going to be a quiz at the end and you can get some free credits. So 2015, rewind back to 10 years, 2015 is actually where we launched in general availability the first Amazon Aurora MySQL compatible edition. This is where our journey actually began.
Exactly 10 years ago.
Exactly 10 years ago. We've come a long way. We've learned a lot. We've done a lot of innovations within the engine, and we continue doing so. 2018, fast forward 3 years, is where Aurora Global Database was launched. This is where we actually also launched our fully serverless V1 version, which is you are able to actually, with a dynamically scaling instance, you're able to scale up, scale down your resources on demand. You don't have to worry about pre-provisioning resources. You don't have to pre-provision compute or storage, etc. So 2018 was again a historical year. Fast forward now to 2025. This is where you'll actually see a lot more innovation has come in. Of course, we launched Aurora DSQL earlier this year, which went in general availability. Global database now supports 10 secondary regions. We also bumped up our storage to actually 256. We doubled the storage from the historical 128 terabytes to 256. Now that is massive.
Actually, we started at 64. So
We
it's
started at 64.
went from 64 to 128 and now to 256.
Exactly. And then there's been like constant incremental improvements. We've worked on switchovers, making those really, really fast for users so that there's lower downtime, etc. We've introduced newer instance classes in line with the innovations from our peer EC2 teams, etc. And we've actually benchmarked and seen 70% improvement in performance using the latest generation Graviton 4 instances. All right, a lot of fun stuff. Let's move on to demo 3, which is actually the most fun part. So what we're going to do here is actually now initiate a switchover. So if I just go up here a little bit, let me just...
And we're doing all of this live, right?
We're doing all of this live. So fingers crossed, live demos work for us. This is demo 3. So this is where, imagine like follow the sun model. And this is where I'm actually, my business right now is active in, we are actually doing this in the afternoon in US East 1. So it's about to get close to business hours, closing the end of the day. And now I want to do a switch over to the Pacific Northwest, which is where things are still peak business, right? So what I'm going to do is from my US East 1, I'm going to fail over to US West 2. And this is the region that I'm going to fail over to. It has my script actually just tracks time, etc. So it's just noon there. It's the middle of the business day. It'll do some pre-checks, etc., etc. And then I'll just say, yes, I want to execute the switchover. You'll notice it's actually a pretty simple one CLI command. It's just switchover global cluster.
Yep.
And what happens here is I'm going to kick off a constant sort of polling script that'll just monitor my switchover. But in the meantime, what I'll do here is you'll notice how my cluster actually changes to switching over status. I'm going to just zoom in a little bit here. And it goes in and modifies a whole bunch of my clusters. What's actually happening under the hood is at this point, we actually drop the connections, existing connections, and we completely stop writes to the database. And what that does is it actually ensure zero data loss. So without any data loss, we are able to actually stop writes automatically, drop connections to your applications, and then synchronize the databases across the regions. We are also going to see how we are going to swap the roles. So our old primary, which is US East 1 in this case, becomes a new secondary. And our new primary, which is going to be US West 2, which is Oregon, will actually become the new primary. And then we will also preserve the topology of the replication, topology of the cluster, and then we'll see how long all of this takes. So while that's happening, I have this monitoring script running. I'm going to just zoom out a little bit. I'll expand this real estate here. You'll notice this is where, so around 3:05:55 is where my primary was disconnected. And this is where switchover is going on. So my cluster is actually getting switched over. I'll just do a couple of refreshes and you'll see that it starts coming back up very quickly.
You know, I remember back in the day when this was launched, it used to take 5 minutes. So I'm counting. Let's see how long it takes now.
It is actually done before we even realized.
Oh, wow.
So 32 seconds is what it all took. And before you realize, you're actually now operating out of the Pacific Northwest. Right.
That's amazing.
So this is pretty awesome. This is like fantastic. But then
I think the coffee is still being made.
The coffee is still being made. Exactly. Now, operationally, right? So I want to look at it operationally from like just a monitoring dashboard view. So CloudWatch gives you a lot of good metrics into how long this whole operation took. You can track other details. You can actually create custom monitoring metrics. So what I have here is a typical CloudWatch dashboard, which will actually monitor a lot of different things. Now I'm monitoring it for the last 12 hours. I have some load running. You'll notice my global replication lag trend is the first metric that I'm tracking. that's always going to be less than 1 second. 1 second is my target metric. This is in milliseconds. This is always going to hover less than 1 second. And if I just browse over, you'll notice it's about 600 milliseconds, 375, blah, blah, blah. It's always going to be less than a second. Now, the per region replication lag is an average metric, which is, again, we are averaging this out over 5 minutes. You can do it over 1 minute, etc. You'll notice, barring a few regions which are, again, just point in time exceeding that threshold of 1 second, average, we are still way below the 1 second mark.
Okay, Cheyenne. So you showed us some console-based demos. You showed us this CloudWatch dashboard. Well, I know you have something really cool planned, and I believe it involves balloons. So what is it?
It does. So, ta-da! Welcome to Aurora Global Taco Tracker. Because you know what? Tracking the world's best tacos in real time actually matters as much as your data. So here is a dashboard that we have built to actually track replication lag in near real time. And what we have is a timeline of our 10-year journey. But then, more importantly, anytime you actually see those balloons, we do have a perfect scenario where at that point of time, all of our secondary regions are less than 1 second.
I count 10. So that means this is perfect 10.
This is perfect 10. And folks in the audience, throw in the chat how many times you see these balloons, because again, there's a prize at the end.
Well, how many times or how many balloons?
How many times these actually show up.
Okay, all right.
Yes. Do make sure that you are also following some of the fun facts that is now popping up on your screen.
Oh, that's really cool. And what I see is that we're literally going from either end of the planet, right? So one end of the world to the other. So
exactly,
all of that under a second. That's just an amazing engineering feat.
Exactly.
Well, that looks fantastic. Well, Cheyenne, I know you have more to show, but unfortunately, we are at the end of this segment. Thank you so much for your time. This was fantastic. We now know really well about global databases. Well, our audience does. Again, hopefully you had a good time. And learned a little more about global databases. Thank you so much for your time, and we will see you in the next segment.
Thank you. Thank you all. Thanks for joining.
Hey folks, welcome back. Thank you so much for continuing to hang out with us today as we continue to celebrate the 10-year anniversary of Amazon Aurora. My name is Adrian San Miguel. I'm a principal partner enterprise architect here at AWS, joined by my homie Aditya. Say hey.
Hey folks, my name is Aditya Saman. I'm a principal database specialist solutions architect, and I get to work on Aurora every day, which is the star of our show. And we have two more stars today in our studio coming to you live, and they are going to talk about RAG. I have no idea what that means. Do you?
No idea. No idea. What is RAG?
Well, thank God we have our SMEs, Cheyenne and Jonathan. Why don't you guys introduce yourselves?
Sure. Thank you. So I'm Jonathan Katz. I'm a principal product manager on the analytics team, previously on the RDS team. I'm also on the core team of the open source Postgres project and have been involved contributing to PGVector, which is a core part of what we're going to talk about today with RAG.
Excellent. Cheyenne?
Hi, folks. Thanks for joining in. I'm Cheyenne. I'm a principal database specialist solutions architect here on the Amazon Aurora team. And yeah, we are going to talk a lot more about rags to riches.
Oh, wow.
Rags to riches. I like what you did there.
No slow clap.
No slow clap. It's got to earn. Slow claps are earned, not given. Sorry.
Well, Jonathan, why don't you tell us more about RAG and PGVector and all that fun stuff?
Yeah, so what we've seen in AI is that we have these very large models that have been trained. We call them foundation models, and they're trained on publicly available information. Now, a lot of information that makes it more useful to use them is in your private databases. So we need a way to be able to take that information, bring it to the foundation model that's cost-effective and fast. And this is where RAG comes in, or retrieval augmented generation. Now, one of the most powerful aspects about RAG is that we can search over information that might not necessarily look like regular data, like numbers. We might search over text or images or videos. And we need a way to be able to take those text and images and videos and compare it to each other.
Right.
And this is where a vector comes in.
Right.
So imagine like I have this cup right here and I have this laptop. Like, what is more similar, like this cup to this cup or this cup to this laptop? And there's this thing called an embedding model, which is able to take this cup and transform it into a vector. And the idea is that the embedding model says, like, hey, these two vectors that represent the cups are more similar to like this cup and this laptop. And that's the foundation of RAG, because then what happens is you perform the search with Amazon Aurora, and you can search over all your cups, using the vectors, and use that to send the information to the foundation model and get that very rich natural language response.
Wow, that is quite complicated. That sounds complicated.
Yeah,
I think Shine is going to make it uncomplicated for us.
I look forward to that.
I will. So if I'm allowed to just bring up my screen for a little bit.
Yeah, let's do that.
So before we begin, 10-year anniversaries don't happen every day.
No.
They do
This
not.
calls for a little bit of a confetti moment.
Yeah.
Confetti moment. What
Oh,
are we
there
doing?
we go.
Okay,
Confetti.
There we go. There we go.
All right. So this is our AI-powered Aurora memory wall. And this actually brings together a lot of what Jonathan just talked about. So what you look on your screen is a snapshot of the evolution of pretty much like a decade of innovation with Amazon Aurora. Right from 2015, which is where we began, which is where Aurora MySQL was actually generally available, all the way to fast forward 2 more years. This is where actually Postgres, the fully Postgres-compatible edition of Amazon Aurora, was born. And this actually led a key evolution, because at this point, we took 2 of the most popular open source engines and put it on a managed database platform. That was kind of a big deal back in 2017. Fast forward to 2022, this is where a lot of you in the audience actually told us, we don't want to deal with this provisioning capacity. We don't want to deal with this undifferentiated heavy lifting of managing servers anymore. So we took a step forward. We basically came up with a version 2 of our Aurora serverless database. Now, this was, again, a game changer. We had basically, you could now scale to hundreds of thousands of transactions in a fraction of a second.
Yeah, we actually saw a really cool demo on that David Vine was showing us earlier today.
Absolutely. In fact, if you're joining us now, if you just rewind and watch Dave's session, you are actually looking at the evolution of serverless, right? So that's a key technology evolution. Fast forward to 2025 is where we are now at the next evolution of serverless, which is truly distributed SQL serverless across the globe. This is Amazon Aurora DSQL, and we will actually have a lot more sessions, so please stay tuned.
So when you say distributed, does that abstract out, continue on that, the ongoing evolution of the decoupling of the compute layer and the storage layer, except you're doing that globally as a service for the customer, so they don't have to go and build it and ask somebody like me to go and have to stand up an entire infrastructure every time that I need a new region or a new code deployment or a new anything. Is that about accurate?
It is. I think it is. But Adrian, I think you are stealing the thunder from some of the upcoming segments. So
a little bit of a teaser there. So you'll probably want to
Shine
hang out
is
and
being very strategic and not giving anything away.
I'm not giving anything away.
I see that. You didn't fall for it.
Yeah, this segment is about using AI to do what you do.
Ooh. I am a very good lazy admin. I would love to see AI do the things that I do.
Awesome.
I keep hearing that the RAGs are supposed to replace humans. Let's see if that's true.
We will see that. We'll find out by the end of this segment. All right. So if we want to pull back the curtain a little bit, let's actually see what's going on. So we have our Aurora Postgres database here, version 17.5. And we talked about a little bit about the vector data type, right? So again, within the Postgres ecosystem, extensions are a way to enable certain things, certain functionality, certain extended sort of capabilities. And a vector is one such capability. So we bring a specialized data structure, such as a vector that will store your vector embeddings. And we also bring some specialized, of course, it's a relational database, so we want to care about performance. So we bring specific indexes. And while I show you the table, Jonathan, what's an index?
Yeah, so when you store data in a table, what happens is that you store every single row in that table. But if you want to do a search over that, say like, hey, find me all the rows around the 10-year Aurora live stream, you normally have to search every single row. And if you have millions and billions of these, that will take a very long time. Like even with globally distributed infrastructure. But an index points to the very specific rows that you may filter by, and you're able to quickly look it up. Now, with vectors, we have to do something special. because vectors are actually very computationally intensive to process, which is a fancy way of saying that it takes a long time to do all those vector comparisons, particularly if you have millions and billions of them. So we do an approximate lookup with the vector search. And there's a special vector index that you see here. It's the HNSW in that little font, which does a very efficient approximate lookup while still returning the answers very quickly.
You know what else is also unique? The demo dance that we forgot to do.
Oh, I guess it's time to do the demo dance?
It is time to do the demo dance. Sometimes it's a shimmy, sometimes it's a little bit of a shuffle, but it does have to be done.
All right.
All right. All right. So next up, so Jonathan talked about a little bit about the approximate neighbor search, right? What does that mean? So if let's say I'm a DBA, I don't really know what that means. I'm going to run a query.
Hey, be careful about what you say to DBAs, okay? They're my homies there.
I knew you were going to catch me on that. All right. So this is a simple query, but not really simple, right? There is a little bit of a nuance here. There's a lot going on. This is a CTE, and to a typical DBA, this actually is a pretty complicated query.
Yes.
But still, if I'm a DBA, I still know the syntax. I know SQL. I know a little bit of how it works. But you'll notice, if I'm looking for a milestone that we launched for Aurora, let's say related to performance, and I don't really know what are the features. I'm looking at the latency. I'm looking at the throughput, et cetera, et cetera. And those could be 100x. Those could be 10x. Those could be 5x. I just don't know. My intention is to search for all features related to performance, but I want to do it via SQL. So this is a query that will actually do that. So I want to look for something like 100x, but I'm specifically specifying that I don't want anything related to performance. So this is an intention of my query, which the semantic search engine should understand and give me, in this case, top 10 results related to that 100x. Now you'll notice in the results, you'll see something like push parallel query, push down processing, 100x. There is Postgres 17 support with faster writes. OK, could be related to performance. There is Aurora MySQL 3.10, parallel query execution. OK. NVMe storage, optimized reads with Aurora Postgres, 8x query acceleration. So without actually looking at a specific performance milestone, I'm able to derive a lot of related features in my milestones table. This is what similarity search or semantic search is at its core.
Yeah, it's all math.
It's all math, which I'm sucking at. So.
Don't we all? Don't we all?
Yes. But this is where the database makes it easy, because you don't need to do the math. You just need to do create extension vector, and it does it for you.
Yeah, and we want to thank our Postgres community for that. I mean, this is all possible because of that. And I know you are a big part of that, Jonathan.
A little bit. One of my favorite projects I worked on was figuring out the costing model for HNSW and helping basically, which says when do you use the index versus when do you use the database, and that's all automated. That's a lot of fun.
He says little. All right, well, Shayan, let's continue with your demo.
Yes. So if you're dialing in now, we talked about a little bit about MCP, but if you're sort of just brand new to the concept, there's a lot of buzzwords these days in the agentic AI world. MCP is another such buzzword, but then it's becoming more and more real as we are progressing. So in this case, think of MCP as just another way, a standard way to communicate with your data sources. The AI applications will use a certain set of tools to connect to your databases, data sources, etc. So in this demo, we also have the MCP integration plugged in. And a couple of things that we've actually weaved into this is one of the core sort of innovations around the Postgres engine has been the Aurora Postgres MCP server. And we also have a bunch of other engine-related MCP servers. If you go to the MCP portal, for example, and if you go to the website, you will notice that there's a whole bunch of MCP servers available here on the AWS portal, including an MCP server for DSQL, an MCP server for MySQL, as well as Postgres, which is what we are using today. So in this case, let's go back to our MCP config file. And here, what you basically specify is Aurora Postgres as our MCP server. Out of the box, what we get with MCPs is a couple of tools, right? So here with Aurora Postgres, we have the run query tool, which will run a certain query on your database. just think of it as a dumb query, like a select query, etc. And there's also a get table schema tool that's available, which will basically describe the table, describe the data structure of the table, etc. The other MCP server that we have also weaved into this demo, which is, again, remember, our AI applications can hallucinate. So there is always a tendency for it to go and do its own thing.
Yeah.
It can go wild. It can just go run crazy. So you just don't have any control over it. So what we want to do as a best practice is to ground those responses that our, let's say, chatbot is giving us.
That's a very parental thing to say, that if you start hallucinating or acting up, you're going to get grounded. I appreciate that. Trust me. I really, really appreciate that.
Well, we want to hear from audience. What are your experiences with AI hallucinating? Let us know. We want to know.
And if it's funny, we might even do some credits or something.
Yeah.
But this is where MCP helps a lot, because it's not just that it grounds the truth; it gives that additional context for how the agent searches over it. So you're basically telling the agent, like, hey, these are your databases. This is where that information lives. Hey, this is the documentation where you can get that truth and not hallucinate and come up with
something
else.
Yeah.
Exactly. So now let's actually look at an MCP query in action.
Okay.
So this is Kiro. Again, folks in the audience, if you haven't tried Kiro, do give it a try. It's easy to get started.
And I see it's very fresh. I see Kiro public preview. So you don't have a special edition.
I don't have any
everything
special editions
available
here.
out there. Yeah.
Yes. So this is where we have our MCP servers defined. If I just go here to my Kiro view, you'll notice my couple of MCP servers. This is basically coming from my MCP config file. And then if I just zoom in a little bit here, I'm going to ask a question. So check in natural language. Note that I don't want to deal with any more of those complicated SQL queries, CDEs. I don't have to have any knowledge of SQL. Now, but there is still a certain nuance to it where I am specifying PGVector. I am specifying semantic search. So there is a little bit of prompt magic that goes into this. So check if
I see that you cleverly avoided prompt engineering.
Yes. I hate engineering. Trust me, I was a dropout. Just kidding. Check if PGVector is installed in the Aurora milestones table. Find all the AI ML related launches that we've done, and then look up the documentation just to ground our responses. And what's an easy way to get started? So let me fire up this query. Kiro is going to come up with a cute little emoji here. It's probably working on its own magic.
It's looking. Look at that. That's awesome.
And
is that supposed to be like a ghost?
It is.
It is a ghost now.
Yeah, there's a whole backstory to that.
Is there?
Yeah.
Do we have time for that?
I don't know. Let's see if we get through the demo.
Okay.
Right.
So what it's doing in the backend is while it's doing a lot of the sort of inventory analysis, it's looking at my config files. Behind the scenes, the magic is it's actually automatically invoking the MCP tools that is at its disposal. And this is what we specify via the mcp.json config file. First, it's going to do the run query via the Aurora Postgres MCP server. It's going to check whether I have PGVector installed, etc. Go look at my milestones table, and then get proper documentation to ground those responses for the chat. So here, of course, it's going to nicely condense that response in a beautiful summary. But then you'll notice this is the power of natural language, right? This is the power of MCP servers, again, a concept by Anthropic, kind of revolutionized the whole industry on how can we actually, with one standardized communication protocol, connect our AI applications across the world to different LLM models, to different agents, to different databases, data sources, etc.
Yeah, and I think that this is so powerful, the MCP protocol itself, because the standardization, as you can see, has brought us MCP servers for pretty much all of our AWS services in a very short while.
Yeah.
So that kind of shows that how strong that foundation is.
Absolutely.
Yep. And we see like the targeted responses you get from it are that much richer. Like when you can point an agent specifically to read the documentation, which we also need to point humans to read the documentation too. But we see like, if you look at that responses, like, hey, this seems like pretty right on in terms of all the things that we've launched for Aurora over the past decade.
Exactly.
All right. So MCP, again, is an awesome tool. It's an awesome introduction to the problem that we are trying to solve, again, is get a lot done with a lot less of the tribal knowledge for SQL, for example. But now we don't actually stop there, right? So typically, MCPs would be a great way to get started, great way to prototype, rapid acceleration on your POCs, etc. But then what we also are looking at is in production, it's not always a simple search, right? It's not always a semantic search. It's not a simple query lookup. There's more to it. And a classic example is if I'm on the Amazon website and I'm trying to search for, let's say, a black iPhone Pro Max 256 gigs versus get me an iPhone. There is a very strong difference in both of those queries, right? So there's this whole multi-step reasoning process that comes in. There is context awareness that comes in. There is this whole concept. In fact, Jonathan has led this in the industry called hybrid search with PGVector. There is a lot more that goes into re-ranking your traditional full-text search versus semantic search, and then kind of giving that end-user experience really solid responses back in that top page of the result. Maybe Jonathan, you can speak about hybrid search a little bit.
Yeah. Well, hybrid search is hybrid search can be viewed in a few ways. Most people view it as combining something like a vector search with a full text search, but effectively you're combining multiple search methods and placing certain weights on each one, and then doing that final re-ranking. And Postgres, maybe a secret about Postgres is that it does have a built-in full text search system and a full text search indexing. And even for the ones that are not built in, there's even more extensions around Postgres that help with that as well. But to the point, we actually also see this technique in the agentic world as well as we go through these searches, because we talked about RAG at the beginning, right, and retrieval augmented generation. And while that does help extend a single prompt that you send to a foundation model, there's more to it. You might need to take this in multiple steps. And this is where agents are such a powerful concept, because you can, they basically will repeatedly go through and keep seeking the answer until they can give that final output, such as the example that we saw in MCP. But there's still ways we can further prompt the agents and help the agents get even more specific answers to those domains.
Speaking of answers, we got a trivia question for you, chat. How does PGVector remember where it left its keys? I know you know the answer. I know you gentlemen know the answer. I am not a DBA, nor do I pretend to be one, but I can wreck a database pretty quickly. If you know the answer, drop it in the chat. We'd love to see it. And before we wrap, I promise we will give you that answer. So, okay. Jonathan, you made mention about how important it is to make the hybrid search available to folks. In your mind, how do you think we should be approaching the next evolution of building and iterating and starting to experiment?
Oof, that's the $64 question right there.
Well, I got about $32.50, so we're gonna have to make do.
Okay, so there's a few areas to start that all these techniques we've talked about build upon themselves. They're iterative. So retrieval augmented generation was the hot topic 2 years ago. Agents are the hot topic today, but you can't have agents without RAG, or you can't have agents without RAG, so to speak, to keep with our pun of the day. But the idea is that all of this is iterative. You're still going to need a way to be able to take your source information, whether it's text or images or videos that you want to search over, and convert them into vectors that you need to be able to perform that search, and you need to store them in a database. So something like Amazon Aurora is still in place there. The big thing that's happening right now with agents is that it's so simple to deploy your own agents and have that, we call it an agentic loop, constantly processing that information. But it all builds on itself. And as we're going to see from this next step of the demo, we're going to build this this agent that's very aware of the decade of innovations across Aurora, and really bring home the concept that everything builds upon itself, even as we get into this agentic AI age.
I dig it. It makes a lot of sense.
Cool.
So, all right. So what Jonathan talked about is exactly what we are going to show next.
Excellent.
And folks in the audience, please do send in your experiences with agentic applications. If you're struggling, if you're on the happy path, do let us know. We love to get your feedback. So let's get into the next segment, which is extending that MCP concept a little bit further. Right, so remember, just to recap, MCP again is, you can think of it as a dumb query engine, which is literally just going in through these tools, is able to extract and glean certain insights, certain information from our database. But then that's where it actually stops. You need to extend in production sometimes cases like hybrid search, cases like extended thinking, cases like contextual awareness. There's a lot more that goes into a production application and a really nice search application at the heart. So this is where agents come in. This is also about autonomous decision making, etc. So on your screen, you'll see the Aurora Memory Wall AI agent, which is actually powered by AWS Strands SDK. Another buzzword. What is AWS Strands SDK?
Well, leave some questions for us.
All right. So, Jonathan, maybe you can get us.
So agents have these common patterns in them, and this is what Strands helps with. Is that Strands is an open source library that lets you build your own agents and assemble the common patterns to be able to point out either specific NCP servers that you need to use or provide the necessary hints to be able to target exactly the information that your agent needs to search for. In this case, it might live within inside an Aurora database. But it makes it just so simple to build these customized agents. Like, it's so much fun to play with.
Yeah.
Absolutely. So speaking of a lot of fun, let's actually look at something in action here. Back to our memory wall.
Okay.
So we have an Aurora AI agent, which is powered by Strands SDK. We're going to start learning a few things about Aurora if you didn't already know it. So I'm going to ask a question, what are Aurora's latest innovations in performance, for example? And while we are bribing the cache gods for an answer,
I appreciate that.
we will actually go in the back end and start looking at what the agent is actually doing, right? So its thinking process. As a developer, I love to peel the onion. I love to look at what's going on behind the scenes. And this is what actually Strands also gives you, a great way to actually log your agentic workflow in your applications to look at what's the thinking process. Is there any debugging that I should put in? Is there any issues around latency, response time, etc.?
And wearing my security hat for a second, it's also like, what data is my agent accessing? And can I add audit trail? Because as agents get more autonomous in modifying the information, it's important to be able to log everything that they're doing.
Exactly. So here, you'll notice that my agent, again, has, remember, the two basic tools. We still have the two basic tools, which is searching the Aurora milestones table, and then searching the Aurora documentation to ground our responses. In this case, we'll see that the agent has actually gone in and looked at the tool number 1, which is searching our database. It did a semantic search. It found some relevant results. It summarized it nicely. But then it also goes to the documentation and kind of summarizes, again, the features, which is more up to date. Again, LLMs in the traditional world are the problem. One of the problems also with LLMs is they are dated. They have a lot of stale information. So keeping it up to date, keeping it relevant has been a historical challenge with LLMs. In this case, we are actually going to the AWS docs, retrieving at real time the up-to-date application, and actually getting these nice little features here. And if we go back to our chat application, we see that Aurora has made significant strides in performance and scaling innovations. And we see a lot of these cool new features coming in. We also have our links to the documentation, etc., the user guide, the cross-database querying, etc., etc. So this is the power of agentic applications, which is where you are actually getting real-time information. The other thing is we also highlighted in our milestones in the Aurora memory wall. So you'll basically see a couple of these launches here highlighted. But that's the power of the agents. You are, again, with a very simple chat application in plain simple English, you are asking for a lot of data to pull together from a lot of different sources, et cetera, et cetera. It could be your database, it could be your documentation, it could be your APIs, it could be files, et cetera. But then we are always sort of up to date with our responses, and we are seeing like real-time sort of application development here with AI applications.
And how long did it take you to code this application, I wonder?
I did wipe code.
Of course you did.
I will be guilty on that. Sorry. So it took me just a week to get a full production application up and running.
And you know, the reason why I ask is I wasn't gonna point out your wipe coding. I was just wondering, like, if you were to do this without MCP, how long it would have taken you? Like, I think that delta is quite big.
It would have taken me 6 months to like a year.
Yeah. Yep. Now, I you know, if I hadn't actually done any development, I would be like, I think you're making that up. But it is so true, right?
It is
like
so true.
The delta between doing wipe coding using MCPs is so huge. compared to what you would do just manually.
Exactly.
And the amount of code too in this, like if we go into it, it's really not all that much code either. That's what's really the powerful part. Like how much like strands encapsulates, how much like the MCP tooling encapsulates, that those interactions between us as mere humans and our AI agents.
Yeah.
AI friends or agents. All right, so we'll do one more fun one.
Okay.
And I love this question, the way the Strands is actually coming up with the response. Explain Aurora's entire 10-year journey using only emojis.
Ooh, that's a good one.
Yeah. Actually, I did a test earlier asking Q to explain to me MCP with only emojis, which it seemed like it was pretty right on, but I don't know how to describe an emoji in words.
Okay.
The trick was to ask our database elves nicely.
There we go.
So there we go. So you look at how Aurora was actually, from its early days, from a baby in 2014, all the way to a decade now. Fast forward, we are now a superhero. Isn't that fantastic?
Yeah, that is amazing. All 3 emojis. I know, by the way, you do owe our audiences some answers.
I do owe you an answer. The answer is, the quick refresher, the trivia question was, how does PGVector remember where it put its keys? And the answer is, it looks for things that are conceptually key-like. It may not be the exact same set of keys, but it's going to have the general idea of what a key looks like to try to do that matching. Is that about accurate?
Yep.
It's taken from the worst possible example of a database person. Well, thank you for making it simple enough for someone even just like me to be able to understand, contextualize, and really get a good understanding of the art of the possible that can be done with this technology. Gentlemen, thank you so much for coming through and hanging out with us today.
Absolutely a pleasure.
Thank you for having us. Yeah, it was wonderful.
Yeah, Aditya, what else do we have going on?
Well, I forget what our next segment is. Gary, can you remind me, please?
No, absolutely. Coming up next, we've got a segment on how to spend $1 on Aurora DSQL, or trying to break $1. But before we get to that, we still have the survey. So please, chat, continue to iterate on that. Give us your feedback. Let us know what you like to see more of. And remember, the first 3,000 responses get a $20 AWS credit. But until then, just hang tight. We'll be right back with another session here in a little bit.
Well, we always had beer on tap, usually in the office. That was always popular with the engineers. Lots of different snacks. Red Twizzlers, I think, was the Red Vines kind of thing was always popular with the engineers as well.
I'm a Skittles guy. I've really had to cut back on the Skittles, but I bring my dog to work a lot. He's convinced me that beef jerky is the best office snack.
Well, my go-to drink is a Negroni, but we were usually doing this on Fridays.
All right, well, welcome back, everyone. We continue to take our journey down the lane of Aurora's innovation, and we continue to celebrate the 10-year anniversary of Amazon Aurora. My name is Aditya Samant. I'm a Principal Database Special Solutions Architect, and I work on Aurora every single day. To take you along on this journey, we have Adrian.
Thank you, Aditya. Hey, everyone. My name is Adrian San Miguel. I'm a principal partner enterprise architect here at AWS, and today we're joined by a legend, the legend, Mark. Mark, would you mind introducing yourself briefly and let us know what you do?
Yeah, hi, everyone, and thanks for having me. My name is Mark. I'm a senior principal engineer. I work on Aurora DSQL. I've been with Amazon for about 15 years. Yeah, it's just super excited to be here and, walk through how you get started with DSQL and what pricing looks like.
Yeah, and we are going to talk about Aurora DSQL. Until now, we talked about serverless databases. We talked about limitless databases. But Aurora DSQL, it's just a baby. It's only 3 months old, even though Aurora is 10 years old. So why don't you tell us a little bit about it before we go down the pricing?
It's actually quite a big coincidence that as we celebrate 10 years, DSQL turns 3 months as of today. Exactly 3 months ago, we were generally available. Yeah,
happy 3 months, DSQL.
I've actually been working on DSQL for a lot longer than 3 months, something like 5 years.
Wow.
Yeah, DSQL is, so it's a distributed SQL product. And, over the years, AWS has built services like S3 and SQS, and we've already built up a set of experience and tools and foundational services that make this all possible.
Yep.
And so DSQL is really sort of taking those tools and learnings and techniques and bringing them to SQL. Yeah.
Yeah, I mean, I think we have had distributed databases, such as DynamoDB, for example, but we have never had a relational distributed database. I think that's kind of the key differentiator here, isn't it?
Yeah, so I mean, Dynamo has just really changed the industry. The Dynamo paper is just a very well-respected piece of research. And customers have been asking us, like, hey, can we get some of the properties that Dynamo has? Like it scales to infinity. When that claim was first made, there was a lot of skepticism around that, but it's really proven to be true. Can we get the ease of management, right? Like in DynamoDB, you're not thinking about provisioning servers, none of that stuff, right? There's no patching. There's no security groups, right? Because it's part of the service. So can we have all of that without giving up on what relational has to offer? Customers love being able to organize their schema in a bunch of tables and do joins and evolve their schema over time. And so how do we do that? Like, that's been the challenge. And, as I said, I've been working on this for a long time. It's not an easy challenge, but that's what DSQL is trying to do.
Yeah, and folks, let us know how long has taken you to patch your fleets. I know I have been involved in with some customers where there's like a year-long cycle of patching your entire fleets. Let us know. Well, speaking of a distributed database, a new distributed database, the fear is always, how much is this going to cost me? Yes, it can scale perpetually to infinity. Is it going to cost me to infinity? So what are you going to show us about cost today? I think the title of this is less than $1. I mean, I'm super, super intrigued.
Right. So, when I think when a lot of customers hear, hey, this service can scale, right? They hear dollars, right? They're like, that sounds expensive, right? But as I said, like DSQL is really trying to do what Dynamo did, right? It's trying to give you that scale, but you can also get started for next to nothing on DynamoDB if you just want to make a table and put a row in. So that's what we're going to do today.
Okay.
To kick off, let's make a cluster. So you'll see from this dropdown, we can pick between single and multi-region. If you stay tuned, you'll get to see what multi-region looks like. But for now, let's do single region.
Okay.
And this is the page.
That's it?
Yeah, there is no scroll bar. I am scrolling. You can see maybe. You can turn off deletion protection. You can change the encryption key, or you can give it a name. So we can say happy birthday.
Happy birthday.
Happy birthday.
Happy birthday. Okay, that's for us. For DSQL, right? Aurora DSQL, 3 months. Here we go. Okay. Hit create, and here we have our cluster that's creating. So just quick question for the audience. What is this going to cost me?
Ooh, that's a good question. I think it's going to cost you hundreds of dollars.
That's it.
$15 an hour, $20 an hour?
Yeah, 15, $20 an hour. Okay. Easy.
Okay, well, while that creates, let's just hop on over to the DSQL pricing page. Okay. So our request-based services like S3, like how do those work, right? So in S3, when you put objects in buckets, you pay for API requests. In DynamoDB, when you put an item into a table, you pay for write operations. When you read items out of tables, you pay for read operations. And like if you have that mental model, that's how DSQL works. So DSQL meters usage, API request usage in these units called DPUs. So distributed processing units. And DPUs represent the work that the SQL engine has to do to process your requests. And when we get into the SQL demo in a minute, I'll sort of show you how to think about that.
Hey, that's not bad. 1 million for $8, I'll take it.
Yeah, so we're going to be doing our demo today in US West too, and it'll be about $8 per million. Okay, so the second thing that happens, just going back to like the S3 or the Dynamo example, you put an object in a bucket, you pay for that API request, and then what? You have to pay to store the data there. DynamoDB, same thing. You put an object in a table, and then you have to pay to keep it there. And DSQL is no different.
Sure.
Just coming back to the DPUs, DSQL does not break out reads and writes in the same way as Dynamo did. And this was like actually a hotly debated topic within the team, how to think about this. And so DSQL being a SQL service, it has that like Lambda DNA to it, right? Like it's running compute, because in SQL you can parse JSON. You can do aggregations. You can say, hey, sum up all the data, group by whatever. And that takes time. It takes CPU instructions. It takes memory. And so what we realized is that there were actually a bunch of physical attributes that we had to account for when we thought about how we meter usage on our service. So there's memory, there's CPU, there's network, and we didn't want to expose everything. Like you're going to pay per packet that we send within our. It's just super complicated for customers, right?
Yeah. Well, while we're talking about Lambda, I have a question for our chat. Do you guys know there's a special name for that micro VM that Lambda uses? Let us know if you know what that name is. We'll give you that answer
That's
today.
a good question.
All right. Sorry. Go ahead, Mark.
Yeah. Okay. So what we have internally, and we're going to get into this in the metrics in a minute, is that we focus our usage on operations for reading data, operations for writing data, and then just a general bucket of compute time. Okay. Let's go to our dashboard. So this cluster should have taken about a minute, 90 seconds to create. It's always something that we're working on to improve. We can click in here.
Isn't that fantastic? Like creating a distributed database in a minute.
It is.
And what? 3 clicks? 4 clicks, maybe.
Yeah.
I didn't count.
And no patching, right?
No patching.
Patching has caused me a lot of trauma in the past. Okay. So I've just clicked the connect button. We're here in Cloud Shell, and it's just going to get us into the database really quickly. I can list the tables that we have. This is really just the Postgres command line. If you're on a Mac and you do brew install, or you're on Ubuntu and you install Postgres, this is just the standard tooling that comes. There's a little bit of integration that we have with IAM so that you don't have to worry about passwords. I think you'll see that in Dan's demo a little bit later today.
And this is true Postgres, right? Like it's not like an interceptor that's translating something. It is actual Postgres.
It's actual Postgres, and on the server side, we are running open source Postgres code. It's heavily modified to work with some of that distributed system technology that I alluded to earlier. So when we commit data in DSQL, it's not going to local SSD. It's going to like a pretty complex journal service that we use in S3 and other AWS services. When we read data, it's coming out of a custom storage engine. But like the brains is Postgres. Okay. Just for ease of demo, what I want to do here is make a table, and then we're going to shift over to the command line. So let's just do create table demo, ID int primary key.
Wow, look at your type. You're really good.
Okay, and then we can just have a look. Okay. So let's say you wanted to understand what you just spent, right? We did something on the service, right? When we created that cluster, we actually had a $0 per month spent. Now I've done something. I have to pay for that, right? So what actually have we done? Well, it turns out there's a couple of kilobytes of data have been stored because a table has a bunch of associated metadata. And so what the query engine is doing here is going through what we call the catalog, and it's saying, hey, what tables do I have? What schemas do I have? Is there a table called demo? And then, okay, there isn't. Let's make one. And it has to register that that table exists. It has to register the column definitions and so on and so forth. And those are turning into internal read and write operations. And this set of read and write operations took time. And so we can actually go and understand that. If you click on the metrics tab, we have a bunch of metrics that go to CloudWatch. These are typically about a minute behind. There's a specific breakout that covers the DPU usage as well as storage size that we spoke about from the pricing page. For this demo, I don't want to be doing something and then be like, let's wait a minute. It's going to be super boring. So
we have some TV magic.
Yeah, I've actually gone and made some clusters already that we can go take a look at. So this cluster over here, the cluster that I've named empty, the only thing that's happened on this cluster is I made it a few minutes ago and then I logged into it once. That's it. Okay. And so if we go to this metrics tab, we can take a look, and you'll see that there's this single data point read DPU. That's not a lot of DPUs, and if you divide it by 1 million, it's nothing, right?
Yeah.
And so what was that read DPU that I paid for just by logging into the cluster? Well, like I had to log in. I had to say, what does this user exist, and like can it even log in, and so on and so forth, right? Okay. What I like to do is take this cluster ID and then actually jump over into the CloudWatch dashboard, because then I can build a custom graph that has everything that I want. So you can click on DSQL, we get metrics by cluster, we can put our ID in, and you can see essentially all those graphs that we were looking at earlier. So you can take compute DPU, you can take write DPU, you can put whatever you want, you can build your own graph, right?
Right.
So here we have a cluster that I made a couple of minutes ago that has 10,000 rows in it. And this is what it looks like. There was a bunch of DPUs to put 10,000 rows in. And you'll see right at the bottom that number 5, there was no data in the cluster. And then there was no more DPU usage because I put my 10,000 rows in. But the cluster's size increased now because we're storing data.
Right. And this is all dynamic.
This is all dynamic, right? And rock steady, no more DPUs, no more cluster, right? So let's actually go do that. Here is a cluster. I'm just logging in from my laptop now. There's no tables. Let's create a table. So I'm going to make this table called Tiny, and I'll explain why in a minute.
Okay.
It's going to have a column called ID. It's going to be a UUID. It's going to be our primary key. It's going to have a default value of give me a random UUID. Then it's going to have another column, which is just a text field.
All standard Postgres.
Yep. So we can read from this table.
I got to say, I'm thoroughly impressed that this has gone through without any typos yet.
I will not disappoint you. Okay.
Seriously.
So let's insert into this table. So insert into Tiny. We only need to specify the value for content because we got this default value. And then we can say hi. Okay. What we can also do here is say, let's generate a bunch of random values. So we're going to say, select, let's say, MD5 of random text from a series with, oh, there's my typo, 1,000 rows. Oh, no.
Oh, yep, there it is.
Okay. 1,000 rows.
There
okay.
we go.
So if we do this a few times, and we get to 10,000, I'm not going to count.
That's close enough.
We go back over here. That's the demo I did.
Yeah.
Right? So 10,000 rows in. Wait a minute. You can do this at home. Make a cluster. Takes you 90 seconds. Connect from the shell. put the commands in, you should see exactly the same thing.
Yeah, do it at home, folks.
But here's the question. What does it cost?
Okay, we'll get there. Okay, if you look at these numbers and convert them into dollars, like 70 over a million, like it's just not a lot of money.
Oh,
right?
wow.
So I've done the math, so you don't have to. We need about 12.5 million rows before we're going to get those DPU costs and the storage costs to get to about $1.
All right.
So let's go and do that.
Okay.
And this is what it's going to land up looking like. I have a little tool that just runs that generation over and over and over again. And actually, let's just do that quickly so you can see what it looks like. Here's a cluster. I'm going to run a workload. I'm going to say I want 10 connections.
Okay.
I'm going to tell you why this is the right math in a minute. That's the number of batches. The workload I want to run is this tiny row workload that we've been running. And we want to say rows per transaction is 1,000. And if you multiply 1,000 by 12,500, you get to the right number of DPUs.
Okay.
And this is going to just chug along and take some time. Eventually, you will get to this value. Now, you can try this at home, and it should be almost exactly the same.
Yeah.
Now, it turns out I've actually done the math wrong because we're not at $1.
Yeah, you're below $1.
Yeah, and the reason for this is I wrote this blog post a couple of months ago that has this exact experiment, and I've noticed that our compute time has actually gone down since then. Because the team has been working on some performance optimizations, which has kind of screwed my math over now. So our compute DPUs aren't what they used to be. They're low, and we're coming out at 0.96.
This goes back to patching. You don't have to patch anything. You just get all the improvements when you create new connections.
Yeah,
fantastic.
No downtime. Nobody had to click an upgrade button, figure out whether they want to do it on Friday or Saturday. It just happened.
That's amazing.
I think at the end of the day, that's what it's all about, Mark. Finding ways to delight customers and individuals that are encountering tech, sometimes for the first time, sometimes you may be an old, seasoned, grizzled vet. Making life easier, getting rid of the undifferentiated heavy lifting, making it easy to get started, and then making it relatively inexpensive to go and start experimenting. That's fantastic.
Yeah, I've started a lot of applications in my career, and many of the ones that matter end up needing data at some point, and it's just such a pleasure to work with DSQL.
It really is.
When you get started, you're not thinking, "Oh my goodness, how do I secure this thing? How do I scale this thing? When am I going to patch it? What's my maintenance window?" None of these questions. You just click that button. So I just want to show you one last thing
and
here.
And we make it hard for you to spend $1. Isn't that amazing?
I had to write software because I didn't want to hit up enter so many times. I'm just going to run my loader again to show you something that's super cool. So if you'll notice, the difference between these two lines is the value to -c. So we had 10 and now we went 1,000 connections. This is just from my laptop. We got up to 1,400 transactions per second, each in doing 1,000 rows. That's 1.5 million rows per second. And I didn't have to pick a different instance type or anything like that. That's just something that DSQL did on my behalf.
By the way, when you're creating tables, I think this is also a differentiator. You don't have to worry about any specific schemes or shards or anything. Just give us a well-formed primary key, and that's all you need to do with DSQL.
Yeah. Okay, so here's the sort of gotcha in my demo.
Okay.
Right? Did we actually spend $1? We was close.
Close enough.
Okay, we round up by 0.96 to 1. Do we get there?
Absolutely. It's close enough for engineering.
It's close enough.
Mark, thank you so much for hanging out with us today. And you've got about a minute left. Is there any parting nuggets of wisdom you'd like to give?
Oh, by the way, I do want to give the answer to the earlier
please
question.
do.
So that VM, micro VM, is called Firecracker. Firecracker. I don't know if how many of you got it. Sorry, go ahead, Mark. Do you have any words of wisdom?
Firecracker is actually the tech we built for Lambda, right? So that's one of those things. Yeah, get started with DSQL. It's super easy. Virtually unlimited scale, high availability, zero infrastructure management, and a free tier. So if you run this experiment today at home, you will be on the free tier.
Yeah, and take that survey and spend that $1 on DSQL.
Or not.
Or not.
Hang tight, folks. We'll be right back with another session. See you soon.
My main advice would be love what you do, and you'll be great at it.
I think the main advice would be to think about the long term. When you're building something, it's very important to get it out. But when stuff lasts for a long period of time, you've got to really think about what the sort of legacy of the software you're building does.
Yeah, I think my advice would be always customer obsessed. Look around the corners to understand what customers really want to be built or what problems they have, versus looking for the cool technology solution that we want to build as engineers. And always think for the long term. That pays dividends once your service is scaling to the scale that you haven't imagined before. So
about advice for developers, to me, it's always about focusing on the customer and executing for them. At Amazon, we talk a lot about working backwards from the customer, and that is so true and so important. No matter how brilliant a technical idea is or how clever you are, if it doesn't translate to customer value, there's no point in doing it. So narrow in on the customer value and then focus on execution. We see the best success from developers that just are relentless to making sure that their idea and their work comes to fruition.
Hey folks, welcome back, and thank you so much for continuing to hang out with us as we celebrate the Amazon Aurora 10-year anniversary. Can you believe it?
I cannot.
Neither can I. My name is Adrian San Miguel. I am a principal partner enterprise architect here at AWS, working with Aurora for quite some time. But my co-host Aditya, you got a bit of a history there too, don't you?
I do, and I am a principal database specialist solutions architect, and I get to work on Aurora every single day. But it is not about us, is it, today? It is about Aurora and its innovation. And we're going to continue down that path, and we are going to learn a little more about strands and MCP. Are you ready?
I am ready.
Well, to tell us more about that, we have Ben. Ben, why don't you introduce yourself?
Awesome. Hey, Aditya. Thanks for having me. I'm Ben. I'm a developer on the DSQL team working with Mark. And yeah, I'm excited to be here to be talking about DSQL and the MCP server integration that we have.
And we did talk about MCP and strands and GenAI and LLM. I call myself acronym guy, but I'm getting lost. Why don't you give us a little bit of a tease about what all of those things mean before we get to the demos?
Yeah, for sure. Let's get into it. There's so much hype thrown around nowadays. There's so many of these different terms and different words. Mm-hmm. Agents, when we talk about them, how I like to think of them is something that you program with natural language. Mm-hmm. And at the end of the day, it's all just code. You're putting code together. You've got some goal that you'd like to achieve. And when we're designing systems, when we're building systems, these are just another tool in the toolkit that we can use.
Sure.
So that's what's really exciting me about getting stuck in with strands. And it's a really simple way to get working with these agents.
And while we have you, I just wanted to ask one question.
Yeah.
Is that I get this quite often, and folks say, well, MCP and API, what's the difference?
Yeah, that's a really good one. So MCP is a flexible protocol for discovering APIs. Now, when you think of standard APIs, you have a model file. You have something that's pretty static. You tell a client what's available. Right. You tell a server what's available, or the server defines what's available. And then those two can communicate using that model. Now with strands, with MCP, it's a way of a server kind of flexibly advertising, here's what my API model is. Here's what you can give me as input, in the form of JSON or whatever input it takes. And here's what I'm going to return to you when you make those calls.
Yeah, and I think the key is you don't need to know the API. you just ask the questions, and then the Gen AI actually does the work. They're discovering the API.
That's kind of the best part.
Yeah.
It takes a lot of the legwork out of it.
All right, so I got to put on my old SecOps hat. Is it secure? I mean, question for the chat: how should you go about securing your Aurora DSQL MCP if you're thinking about going out and building it? And Ben, I'd love to put you on the spot and see what you've got for us.
Yeah, for sure. I mean, we can take a look at that. So I'm in demo mode, so I like to live dangerously.
Oh, let's do it.
But when you are working on these demos, okay, let me show you what it looks like to interact with Aurora DSQL's MCP server. So off in the background, I've gone and I've set this up so I can interact with it. You know, a lot of you may be familiar with your IDEs if you've got like QChat, or maybe you're using C-Line. You might recognize how it looks to set up an MCP server for one of these new AI integrations. See, it's pretty simple. I put in my cluster, I put in my region, I put in the user I want to use. Here, admin, living dangerously. When you are creating a kind of production instantiation of this, you really should think about scoping it down to the precise users and the precise permissions that you want to use. So, I mean, a lot of you are probably familiar using Postgres in the past. DSQL is a Postgres-compatible database. Everything you know about Postgres in terms of roles and users still applies. You can scope down a role. You can give it access to a schema, or read-only access or write-only access. And that still applies here. It's about scoping your servers and your configuration down to that minimal access for security.
And I also see that you're auto-approving reads, but not writes.
Yeah, exactly. That's another thing that you can do. You can say, okay, with this configuration, you know, MCP, you want to auto-approve certain tools. In my dev environment, I'm thinking reads are fine. Just go ahead, read the data and spit it back to me. It's my data in the first place. So yeah, let's take a look at how the MCP can kind of interact with my cluster and see what schemas do I have in my DSQL cluster. So a lot of this might be familiar if you've already been following us along these presentations and kind of seen gyms earlier. In much the same way, the DSQL MCP server is able to kind of make these read transactions against the database, figure out what's going on. Okay, so you can see I've loaded up the IMDb database there. I've got a little bit of information. What tables do I have?
There's that talking to the database that we were saying before.
Somebody's got to put it in line. Somebody's got to talk to it.
Yeah. And it's such a powerful thing to be able to talk to your database in natural language. You know, I don't have to kind of think of exactly what are the SQL queries that I'm writing in any one moment. Like all of that kind of losing context. Like
I don't know, Ben. Everybody has been talking about natural language. What is an unnatural language?
What is an
Please
unnatural
do tell.
language? I mean, there are some programming languages out there I would certainly consider unnatural.
Okay. We're not using any of those.
No. So yeah, maybe I could ask it, what does the data in episodes look like? And it's probably going to go and get me a sample and tell me, and you know, that's going to be helpful for if I'm using this in developing. And I want to figure out, you know, exactly, okay, what's the current shape of my dev database? How could I make these new queries or these new features that I'm working on work with it?
I also see that you're very trusting of your MCP. Jimbo wasn't. He was saying yes every time. You're just like, I trust you.
Read-only query. I mean, that's the benefit. You can, because these MCPs provide different kind of tools, they allow you to really focus on, okay, what's allowed with this one. With read-only query, I know that's only going to be reading data. It's not going to be writing anything.
Sure, makes sense to me.
So I'm fine with that. Okay. So yeah, that's a little introduction to how you might use it in a dev environment. Why don't we get into the Strands agents and see how easy it is to build an agent and kind of demystify that part of things. So you see here, I've got a little Python script, and if you can read those 5 lines, that's how you create an agent.
Wow. 1, 2, 3, 4, 5. Literally 5 lines.
5 lines.
Yeah. So it's not much. Like here in the background, Strands is using Bedrock for me. And you can provide your own model provider. You know, if you have a locally hosted model, if you're with any other API provider, and all that is the LLM that's backing it. So Strands is doing the kind of heavy lifting of orchestrating, you know, I'm going to send this response, I'm going to get some tokens back, I'm going to get some information back, and then figure out what to do next. But the model, you get to pick that. You see here I'm using Claude 3.5 Sonnet. I think it's a pretty good one. It's working well for my purposes. And you see also I have a system prompt. And this is kind of telling the model what it can do, or telling the agent, rather, what it can do. This is what you really want to think about when you're kind of like programming these agents. I'm telling it, you know, it's got access to this IMDb database with this schema, and I'm asking it to answer questions about movies using these appropriate indexes.
Sure.
So you're thinking, like, how does it know that it has access to that database?
It's got to go ask.
Yeah.
It's got to go ask. And this is the kind of magic of like how you insert that into the agent. You tell it which tools it has. Here I've given it the DSQL client, and up here is where we set that. And it looks exactly like the configuration I had for QChat, right? I'm telling it the cluster endpoint, telling it the region, the database user. So let's see what it's like to run a little simple query against that. So I've got this here.
I think this is why they say the MCP is like the USB-C of the internet, right? Like you have the same configurations regardless of what tool you're using.
Yeah. That's the really great thing about a flexible protocol. When you think about so many advancements in programming and technology, they're better and better abstractions that let us build on top of other things like HTTP, the web in general, and MCP is kind of a new layer of that. While it's very, very new, you know, only came out in November, it's being used more and more.
Yeah, and it has proliferated already so much because of that simplicity.
Yeah, I think people really appreciate the flexibility.
Yeah, speaking of flexible, I do fancy myself a bit of a movie buff, and we were talking with Jimbo about his favorite movie, which, for the record, if you didn't catch it, was My Cousin Vinny. You're asking here in your program to go out and search the IMDb database looking for anything with Aurora in the title.
Yeah.
And for the life of me, I could only think of two, and it was number 3 and number 4 on this list. This is crazy.
Yeah, so it's gone out and it's kind of fetched that information for me. It's able to answer my query, you know, as vague as it is and as general as it is. And now it's come back with a lot of information, and I didn't have to write a lick of SQL.
You know what? I have an idea. Why don't we turn these 4 hours into an Aurora movie?
Let's do it.
Gonna get some birthday theme in there as well.
Yeah.
There we go.
Yeah. Okay. So yeah, that's not the only thing that you can do with the agents. You can also feed the output of one into the other. You got to remember that agents in the end are just programs, and they, just like other programs, they output stuff. So you can see here I've got this kind of multiple agent setup. I'm creating one first, and then putting in this like initial prompt where I'm asking it to explore and describe the database schema that there is, and then I take that prompt, that DB info prompt, and feed it in as the system prompt to another agent, which I can then use to query the database further. So it's like the first one, if you'll notice, the first one kind of struggled with the queries there. It had to take a couple of attempts. And that's the cool thing about these agents is they are able to like fail, get some things wrong, and then learn and adapt. You know, where with a human, it would take me a couple of attempts to write the exact SQL query that I want.
Lots of Googling, lots of forehead against the desk, lots of frustration, lots of, why isn't it working? Like I may have done
and I
last
love
week.
how polite they are, too. Like, they
Whoops,
apologize.
I'm sorry, I couldn't do it.
Yeah, they are very polite. But we can take that info that the first agent has kind of output for us, and feed that into another one, which would then be better set up to answer our questions. And kind of what I'm getting at here is more the general principle of using these as components of a broader system. You know, while this is a super simple example in and of itself, you know, get some information about this database and help me query it, you can integrate that wherever you like in your programming lifecycle, whether that's in prototyping an application or as part of a component in a broader, more reliable system.
Yeah. And, you know, I asked this question to Cheyenne earlier before as well. Like, this seems like a fairly complicated thing to do. But how long did it take for you to program this with MCP?
It was really brief. I mean, you can see the files of code. We've put them up on GitHub as well, so they should be available for you guys at home to kind of follow along and look at the code that we're running. It didn't take me long at all. Like under a day to go through all 3 of these examples here and get them to a working state. Whereas if
and you know, Cheyenne and me, in fact, we're not hardcore developers. Cheyenne said it would have taken him 6 months. You are like in the thick of it, like you're developing every day. You're an SDE. What do you think that differentiation is for you? Like, how long would it have taken you without an MCP?
I mean, for similar applications, like a week, couple of weeks.
Wow.
You know, just to do those components.
Wow.
And I think the benefit of these, like. So we've gone through this kind of dynamic query. You'll see that the first agent spit out all this information and then helps the next agent kind of query and say, you know, help it ask better questions or respond better. Let's move on to the kind of multi-agent application that I wanted to talk about.
Okay, yeah.
'Cause this is kind of more of a like full end-to-end application where I'm getting data from one place, I'm putting it in my DSQL database, and then I'm trying to get it out at the other end. Because I think this is the thing that would take me a much longer time to kind of do each component, whereas with these strands, with these agents, I can really prototype an end-to-end application in under a day.
Wow, that is amazing.
So what I have here is a couple of agent prompts. Again, the first kind of setting up the database. I wanted to set up a schema for storing this information, gathering this kind of information. So I've got some kind of like data source for these news articles. And then I have another prompt that handles reading these news articles from the source. Here they're just files from disk, but you could imagine they're an API which it's going and fetching, it's reading, and insert data about that into the database. And then finally, I have one at the end which takes that information, the schema, just like we were doing before, and helps me read it out again. So let's see what that looks like to run.
Okay, well, let's see. What have we got here? We got cooking.
So this is the part that's inserting the data. So I'm spinning this off in a thread.
Okay.
So you see here, it's just starting to chew through them.
I was about to ask the chat, how long do you think this was going to take? But never mind. I'll shut up.
Well, at least it doesn't say perfect every time it goes.
Hey, well, nobody's perfect.
Nobody's perfect. Okay, and then off in this one, let's do the part where we can query that database at the end of the day and see kind of what data that this other agent is putting in.
Okay.
So this is when I refer to them, and that setup's already complete. So can you tell me about some articles on AI in the database?
You guys have impressive typing.
That is one of the biggest parts of the day job, and you should see the keyboards.
They're all beaten down, worn down, scraped up, yeah.
Hammered, strange shapes. I know I'm a big fan of Kinesis.
Do you use one of those RGB keyboards? I love those.
I'm not big on the RBG, but it's got to be split. It's got to be split. Cool. And you can see here, so we've got this coordination of 2 agents. We've got one on the side that's writing, that's already like crafting an input into this database. And the other one which can take that input and answer some questions for me. Like you can see the training data or the data that I've put into this database is a little behind. But it was able to fetch that kind of no problem, and maybe I could help drill down on a couple more features of each of these. You know.
Okay. It's a very specific question.
Well, let's see. That was part of what I asked the insert agent, that I wanted it to kind of focus on what locations, the people that were involved, and see if it gives any more information there. Oh. And yeah, you see each of these news articles, they have locations involved that we're able to retrieve nice and easily. And meanwhile, that insert agent is still chugging its way through more and more of these articles.
That's pretty fantastic to see, kind of a peek behind the curtain how the sausage is made. This is, I gotta say, coming from an InfraOps background, this is kind of humbling to see technology used in this way to allow you to be as flexible as your imagination lets you.
It really is. And what I like about this is that it's so extensible. If you want to add, say, I don't know, latitude, longitude, look up, you just add another tool, and that tool can do that for you, and then you add another tool, and you add another tool, and you just keep extending the functionality of your app. It's so cool.
Just keep iterating. And maybe that was a good time to talk about why we think that DSQL is such a great fit for these kinds of tools, and why we built the MCP server in the first place.
And the question is, can you spend more than $1?
You definitely can. I think if you try hard, you let it run a lot. But yeah, DSQL, because it's pay-as-you-go, because it's fully serverless, because it's zero infrastructure management, this is why we think it's a good fit for these kind of agents. You don't have to worry about instance costs being spun up the second you start using something. And so when you're prototyping, or even when you're working on applications that are going to deploy in multiple places, lots and lots of times, you can use a cluster as your unit of isolation. You can start getting those responses back and only pay for what you use.
And then you can extend it across regions and not worry about having a potential failure of an entire region, which is very rare, by the way, or impossible.
Yeah, exactly. Like the single region clusters, those are all redundant across 3 availability zones, and those offer up to 4 nines of availability. The multi-region clusters, in that configuration, you've got 5 nines. So kind of pretty crazy availability. And of course the durability benefits that come from that, being able to recover at a specific point in time.
I forget. I don't know if our audience knows what is 5 nines of availability. How many seconds or minutes of downtime?
I used to know this. I think it was like 36 minutes per year or something like that.
That's a great question. I
fact
can't
check
do the
me,
math.
chat, please. But we're getting towards the end of the time that we do have here, Ben. We got about 2 minutes. Is there any nuggets of wisdom you'd like to leave for the audience? Some homework, where they can learn to get started, anything like that?
Yeah, for sure. I'd really encourage checking out the Strands SDK, checking out the docs on how to get started. DSQL, we have a generous free tier, as Mark was talking about before. So do get started. Do try it out at home and see what you can build. I'd be really excited to see what you can build. We also have the links here to DSQL's MCP server, so you can get started, and the code for my demo. If you want to use that as a launch pad for figuring out, okay, what can I build that's going to be way cooler than this guy's?
Yeah, and easiest way to do that, folks, is by taking those surveys, and first 3,000 of you are going to get $20. Spend some of that money on DSQL. And all of this is on GitHub, right?
Yep. Yeah, all available now.
Awesome. Ben, thank you so much. In chat, I know we had asked you a question earlier about how you should secure your Aurora DSQL MCP. Ben did give us the answer. First, you don't want to pass allow rights blindly. And then, of course, you want to connect with the properly scoped down user with write permissions disabled.
Yep.
Is that about accurate?
Yeah, that's accurate.
Awesome. Ben, thank you so much for hanging out with us today. Folks, stay tuned. We've got one last session that you're not going to want to miss. I have a very, very good feeling that we're going to discover how multi-region active-active works.
Well, we'll see about that.
We'll see. Stay tuned.
Sports is really about timing. Being in that exciting moment when Ronaldo scores a goal, or when a horse makes a big run and just clears the rest by a length.
Here at other levels, our goal is to capture some of those emotions, combine it with behavioural information, and then turn it into a personalised, Gen AI-led, human-facing experience, and do all of that in near real time.
The tools and services provided by AWS are quite liberating for content creation. The AWS Builder Studio has really allowed us to have that expertise at hand, to guide us to build a path forward to get from conception to execution.
With the evolution of some of the new Gen AI technologies, we can create rich video experiences and basically humanize the whole engagement process.
Amazon Bedrock foundation models have allowed us to really utilize the best generative AI models that are available. Amazon Poly is an amazing text-to-speech engine. It's brilliant for voice synthesis. You can create a perfect human being by all accounts. They can talk to you, they can interact with you. We can customize an ambassador that's 100% on brand. I can take a text description and create a person essentially, down to the voice, the look, everything that you need to get your brand message across.
Sport creates the most passion and excitement. Fans just get so energized. They love the moment. If you're going to be a brand and going to respond to that effectively, then you're having to deliver experiences at the same pace, at the same scale, that are really sort of hyper-personalized, because you're also competing for attention along with social media and everyone else out there. It's about matching the experience to the fans' expectation. And the fans have a very high expectation of passion and fun and enjoyment, and that's the opportunity in front of us.
All right, well, welcome back, everyone, and we continue our journey down the Aurora innovation. Along with two hosts, my name is Aditya Samant. I'm a Principal Database Specialist Solutions Architect, and I get to work on Aurora, which is the star of the show. And along with me, I have Adrian.
Hey, folks, my name is Adrian. I am Aditya's co-host today. My name is Adrian, as you mentioned, and it's been a day.
It has been a long day.
Today and most days, I'm a principal partner, enterprise architect here at AWS, working a lot with our tech partners. But interestingly enough, this is one of the highlights of what I get to do as a bit of an elective. I get to talk shop with different service team owners, different specialist SAs, and then, of course, with you, chat. Hi, how are you? Let us know in the comments how you're doing. But here we're actually wanting to dig into something that is pretty important to me as an infra and ops guy. How do you do cross-region availability in a sensible way with Aurora? I've never been able to answer this question, but I have a good feeling that sitting here with Dan, we're going to get pretty close to perfect on that answer. Is that about right, Dan?
Find out myself.
Oh, Dan, why don't you introduce yourself?
Sure. My name is not Adrian. My name is Dan Blinner. I'm a solutions architect, and I specialize in Aurora DSQL.
Excellent, Dan. Well, Dan, I know you're going to talk about multi-region Aurora DSQL, but we have a quick bit of trivia before we get started.
Oh, no.
So the question for the audience is, what is a multi-region Aurora DSQL cluster made of? Is it A, 2 regions, B, 2 link clusters and a witness region, C, up to 5 regions? I think we're going to find out throughout this session, aren't we?
Absolutely, yeah.
All right, well, why don't you tell us what this specific issue is of this multi-region availability, and how does DSQL solve it?
Yeah, sure. So one of the things that differentiates DSQL from a lot of our other database products with respect to multi-region is that it uses synchronous cross-region replication. It is always strongly consistent in both regions. So if you commit a transaction in one region, that data is immediately available in the other region. So there's no replication lag, there's no eventual consistency. And so that's one of the primary differentiators with Aurora DSQL. And what that means is it makes DSQL great for multi-region active-active use cases where you're running your entire application stack in both regions. You're taking both region rights in both those regions. So with DSQL, there's no primary or secondary region relationship. They're both equal peers. They can both take both region rights equally. And with the database being totally serverless, it makes it real easy because there's no infrastructure to manage or to provision. And it makes the overall process of running a multi-region database much easier than otherwise.
Yeah, well, you say that, but we want to see. Truth's in the pudding, man, because no replication lag, ability to read write from any it sounds magic. I mean, how are you beating the rules of physics?
Well, you can't beat the rules of physics. You do if your clusters are far away. You still have to spend some cross-region latency, but there are some optimizations that make that a lot easier. Okay. And so let me show you how to set up a multi-region cluster, and then we can talk about. I can demonstrate how cross-region replication works with Aurora DSQL. So here we are in the DSQL console. I've got two tabs open here. Okay. One is in US East 1 or Northern Virginia, and the other is in US East 2 or in Ohio. Now, when you create a multi-region cluster with Aurora DSQL, there's actually 3 regions. There's 2 linked clusters, and then there's a third region called a witness region. And that witness region has 2 primary roles. Number 1, it participates in transaction commit quorum, and number 2, it votes in the case of a network partition. It decides which cluster stays in and which cluster gets voted off the island, essentially. And so when we create a multi-region cluster, we often talk about 2 regions, but you really get 3. The witness region is not a resource that you can use, but it is a very important part of a multi-region cluster.
Okay, so what you're saying is that it stays consistent and it stays up.
Absolutely, absolutely.
So for audiences, what does that mean in terms of the CAP theorem? We would love to hear from you.
Yeah, okay, sure. So you can call DSQL a CP database.
Oh, you gave the answer, man. That was for them.
Oh, no, okay. But no, that isn't the whole story because with Aurora DSQL, because we're multi-AZ and we're multi-region, we can offer strong consistency even in the face of a loss of an AZ or even in the face of a loss of a region. So it's CP but also A. So you can always stay consistent, always available, even in the face of a region outage or an AZ outage.
Okay. You redeemed yourself.
All right, good.
All right, well, let's see the demo.
All right, cool. So again, let me go to North Virginia here. Okay. I'll create cluster. I'll pick a multi-region cluster. Okay. You can run DSQL in single region mode as well. It works fantastic in single region mode, but we're going to do multi-region for this. And so here is the super complicated workflow for creating a multi-region active-active database. So we can decide if we want deletion protection on or off. Here we're going to pick the witness region. So we're in US East 1. We're going to pick the witness region. We never send data someplace that you don't know about. So you pick all the regions involved in your cluster. We're not going to send your data to a different country, to a different place. You pick everything with DSQL. And so what we're going to do now is we're going to give this a name as well. We're just going to call it my cluster, and I'm going to hit create. And that's it for this side of the cluster. And so now what I'll do is I'll click complete multi-region setup, and I'll pick my other region, my other data region or linked cluster region. This is US East 2, and I'll hit that. And that's going to ask me the same questions again. So I'll just go down here and I'll just say, my cluster again. It doesn't need to be the same name, but we'll do that for the sake of this demo.
Okay. Well, that's I don't know. That's maybe like 5 or 6 clicks, even when you're creating multi-region cluster. That's amazing.
Well, I do have 1 or 2 more left, so
okay.
I think we might hit 6 or 7.
How dare you get us up to double-digit clicks, maybe?
So now we have to finish this process. We have to say peer in US East 1, and then over in US East 1, we have to confirm that we're going to peer. So it's like a friend request, I guess.
Are we going to add you to the top 8 on the wall? That's a big question. I might have dated myself with that reference, but it is my space to do what I choose.
I see what you did there.
Thank you.
All right. So now this is creating. So if I go back to here, let's just clear that. We'll look at my clusters, and you'll see here in US East 1, this is creating. And I believe this is Ohio. This is also creating. Now, this is going to take a few minutes to get done. So I've got another cluster already called demo that's already spun up. So let me show you what that looks like. So if I click into the demo cluster, this is just one I created a little while ago. Notice that there's not much here. There's no infrastructure for you to see. There's nothing to provision. There's no capacity that you have to specify.
No VPCs?
No VPCs, no security groups, no subnet groups. You don't have to worry about a writer node and a read replica and what happens if the writer fails over. There's none of that because this database is completely serverless.
All right, you're out of control because should you or any DBA or anybody come up to an infrastructure person or an ops person or even just like a dev, say, hey, go provision me this environment capable of X million IOPS or this type of performance, and here's my P90 and latency, and you go and try to figure out exactly what it is that you're trying to do, That's all obfuscated. That's a couple clicks away. That's just not even having to worry about the problem at all. That's fantastic.
Absolutely. This database scales on your behalf from 0 to massive, and it remains available. So we automatically handle component failure, AZ failure, and even region failure automatically for you.
Wow.
So as I click through, there's not much here. There's the Amazon resource name. There's the endpoint. This is the host name that you would plug into your driver or database tool. There's a cluster ID. I can go into peers, and you can see here this cluster is in US East 1. Actually, I'm in Ohio right now, so you'll see my other side is in US East 1, and I'm using a witness in US West 2. And then there's some metrics. I can look at my CloudWatch metrics to see what my database is doing. Notice you're not going to see things like CPU or IO, no low-level host information. It's all about connections, transactions, and throughput. And then you can tag it as usual. But this is it. This is all you get with the console. There's not much to manage here. You basically just need to manage backups and then make sure that your schema is correct.
Yeah, you click a few buttons and you have a multi-region cluster that doesn't require fail or failback. Pretty amazing.
That's right. Yeah,
that is pretty amazing. But I'm a very, very visual person. How can I trust it?
How can you trust?
How can I trust my write in my primary region goes to the secondary region? I'm not having deadlocks or anything like that. Can we take a look at something like that? Because I remember in my primitive brain many, many years ago having resource contention with devs, both working in the database at the exact same time, and the scheduling app went down, and we were down for like 2 weeks.
Yeah, that's a big concern with multi-region databases is collision detection or conflict resolution, and DSQL does that for you automatically. So
really?
Strangely enough, I have a demo prepared to show you exactly how that works.
Ooh, all right.
So I've got 2 terminal sessions here. One is in US East 1, one is in US East 2. I'm going to connect to my database just using pSQL, just normal standard Postgres tools, nothing special to download or use. The only thing different is that we don't support password auth. We use IAMAuth, and that means we have to generate a token. So I'll do that with this command, and then I'll log in with pSQL. So I've got a session now in US East 1, and I'm going to do the same thing over in US East 2. All right.
Hey, Dan, for the benefit of audience that may or may not know, what exactly is a token in this context?
Yeah, so it's a piece of encryption information that represents your identity, and it is used in the place of a password. It's temporary, and so those tokens expire, and that way there's no sort of fetching passwords and no possibility of losing passwords.
Or writing them under the keyboard.
Or there's no post-it note on the laptop, or you don't write on the back of your hand. So it's a lot more secure.
It is kind of the gold standard in passwords, right? Like it's complex. It expires within a few minutes, and you can't lose it.
No, you can't lose it. Nope.
Well, that's pretty cool.
Yeah, cool. All right. So I've got 2 sessions logged in. Let's see. So let me just see if I have my table here. Okay. So I'll do a very complicated query. Select star from my demo table, and you can see that table does not yet exist. So let me just make sure it doesn't exist over in the other region.
Okay.
So nothing up my sleeve. So now let me create this table, create table demo, ID, int primary key. Oops, if I can type today. And we'll do a message with 50 characters.
Unfortunately for Dan, the typing bar has been set very high today.
That's what I keep hearing. So I'm hoping to live up to that expectation. So now if I do a query, you can see the table's empty, and if I do the same thing over in Ohio, you'll see that that table exists. So I only had to create the table in one place, and it automatically replicated to the other. Now if I do an insert here, insert into demo values 10 for Aurora's 10-year anniversary. We'll say
happy birthday, Aurora.
Happy birthday, Aurora! Exclamation, exclamation.
Smiley face. No, you can't put the
That's
smiley face.
Yeah.
It'll just live in our hearts.
Yeah. Now, if I do a select, you'll see there it is. And if I do a select over in the other region, you'll see that it is there as well. And now if I insert a record here, insert into demo values 20, can't wait for DSQL to be 10. Still a few years left to go there. All right, and if we do a select again, you'll see that we have both records. Here we have both records. Now, so the replication is bidirectional. This means you can have true active-active applications. Your application stack can run in both regions. You don't need primary, secondary. You don't need sort of a primary failover mode. You can do active-active. And you can use latency-based routing to route customers to your application stack in a region that is nearest to them. Okay.
Which begs the question, if you're trying to update the same thing from both regions at the same time,
Yes.
what happens?
Yeah, well, let me show you. So this database is built to handle that for you. So one thing that we do with DSQL is we use optimistic concurrency control. There's no pessimistic locking whatsoever in the database. There's a lot of reasons for that. It gives great performance at scale. But what it means is that as you're writing transactions, you don't have to worry about locking. You don't have to worry about what else is happening on the system. You just sort of write your naive queries and let the database protect you from concurrency collisions. So let me show you how that works.
And no locking means no blocking and no deadlocks.
Absolutely
How cool
right.
is that?
Yeah, that's right. All right, so I'll start a transaction here, and I'll update demo. We'll set my message equal to updated in US East 1, where ID equals 10. Okay, so I'll do my update, but I won't commit my transaction just yet. This transaction is still open.
Okay.
So over here, I'll say update demo set message equal to ha ha ha, where ID, where ID equals 10, okay? So now this is going to auto-commit, okay? So this transaction is committed. So now if I do a select, you'll see there's my new value. And now if I try to commit over here, even though this update was made in the other region, in Ohio, if I try to commit my transaction here, the database knows that the row I'm trying to update has been updated by another transaction, even though it's in the other region, and it throws this error. And so as a developer, what I should do is catch this exception and be willing to retry my transaction. So instead of locking records and maybe waiting for the lock to clear, instead I'm just going to run my transaction and catch this error if the database protects me from a concurrency collision. So that's the overall model.
And I think this is important in terms of relational databases, because relational databases give you that consistency, right? Strong consistency. It doesn't matter where you wrote it, you can always read it.
Absolutely.
As opposed to something like a NoSQL database, which is, where we're making that change in a bespoke manner. We are saying, well, last writer wins and you may lose data.
Right.
Where in this case, the first writer wins.
Absolutely. Yep. And so what this means is that what I'm going to do is I'm going to retry my transaction, and I'm going to rerun all my application logic in that transaction, which means that I'm going to reread the data, and I may make a different business decision based on the new state of the data. And so this allows me to to catch changes and not have to worry about what might be happening somewhere else in the other region. So this whole retry logic is a really great way of running transactions at scale in a multi-region active-active way.
Makes sense.
Also understand that concurrency collisions are a natural part of using a database. So this is not a problem. It's just, that's always going to happen with a database, especially, with a complicated application or under heavy load. But what you do need to worry about, though, is making sure that you don't get a lot of these. So getting OCC conflicts is fine, but getting a lot of them is not fine. And so what you want to do is make sure that you're not having hot write keys. You want to design your data model such that you don't have a whole bunch of processes trying to update the same row at the same time, because that will cause a lot of concurrency collisions and slow your performance down. So make sure your writes are distributed across your key space.
And also, I think one of the things that we want to do in DSQL is to keep those transactions short.
Yes, short, fast transactions. So DSQL is optimized for OLTP transactions. So you want short, fast transactions where there is a transaction timeout of 5 minutes, and so you're just not going to have long-running queries. And so DSQL is not optimized for OLAP or for heavy-duty reporting workloads. Short, fast transactions is what you want with DSQL.
Yeah, and the other effect of having long transactions is that they may never be able to commit.
Yeah, that's true. Yeah. Yep, absolutely. So with these short, fast transactions, that whatever's going to happen is going to happen quickly. So you can't start a transaction with millions of rows and then wait for it to commit an hour later. You just can't do that. So that also means that you can't tie up resources. And with an optimistic concurrency database, there's no cross-region lock management either. So if that transaction fails, there's no cleanup to do because of open locks or whatever. So
there's no rollback.
Exactly right. Yep.
There's nothing to roll back, right?
That's right.
Yeah. And so with this model, I think we probably, the developers may have to do a little bit of change in the way they write code.
Yeah, absolutely. So instead of taking a lock and waiting on that lock, or maybe timing out in the lock, the overall model is just try your transaction and be willing to retry up to a certain number of times. So maybe you try up to 5 times, maybe you add a bit of exponential backoff and jitter, which is a lot easier than it sounds, just to make sure that your transactions don't recollide over and over again. But that's the overall model, and that really will protect you from concurrency collisions, and it'll allow you to really run a lot of transactions at scale.
Yeah, and we have some great guidance available on how to program and how to avoid those collisions and how to keep scaling, like Mark said, to infinity.
Absolutely.
And beyond, potentially.
And to be
yeah.
Well, folks, thank you so much for tuning in. And Dan, seriously, thank you for helping demystify this. Sure. But to answer the question, trivia question that Aditya asked earlier, you already gave it to us. It's 2 linked clusters and a witness region that comprise an Aurora DSQL cluster. So thank you so much for hanging in there and participating. Dan, we got about a minute left. Any last-minute guidance that you might be able to offer the audience?
Absolutely. Start playing with DSQL today. We'd love to get about 100 of you to start spinning up clusters. Go ahead.
And how are you going to do that? This is the last chance to take that survey and claim those $20 for doing those experiments with DSQL.
And come see us at reInvent. We're running some hands-on workshops. I'll be out there, so come stop by and learn more about DSQL.
Me too.
Oh, cool.
Come see us.
Me 3. But until then, hang tight. We'll be right back as we begin our wrap-up. It's been a day. We're glad you hung out with us, so come back and see us. We'll be here waiting for you.
Access to quality education has the power to transform lives. Yet millions of underserved learners worldwide face barriers in accessing digital learning opportunities, widening the global education divide. Organizations aiming to bridge this gap may lack the resources to leverage advanced cloud technologies and AI, making it challenging to innovate and scale impactful learning solutions to reach those who need transformative education tools. Addressing this resource gap is crucial to unlocking impactful solutions in the education technology sector. Amazon is making a commitment to expand access to digital education for underserved learners worldwide. We're powering the future of learning by committing up to $100 million in cloud computing credits to transform educational innovation from idea to global impact. Organizations can take advantage of expert AWS technical guidance to migrate, build, and optimize the use of cloud technologies. By leveraging AI services like Amazon Bedrock and Amazon Q, organizations can transform educators' time. For example, Code.org automates assessments, freeing educators to focus on personalized teaching. Rocket Learning delivers data-driven insights to enhance education delivery in rural communities of India. Amazon is committed to closing the education gap, creating equitable opportunities for learners worldwide. Together, we can unlock the potential of technology to build a brighter, more inclusive future. Apply now to the AWS Education Equity Initiative.
All right, all. Well, welcome back. As we start to wind down this session, we are still your hosts. My name is Aditya Samant. I'm a Principal Database Special Solutions Architect, and I get to work on Aurora every single day. And with me, I have Adrian.
Hey, folks. My name is Adrian. I'm still Adrian, apparently. I'm a Principal Enterprise Architect here at AWS. I work a ton with tech partners and had the privilege of getting to work with service teams like the Aurora folks. I got to say, it's been a day.
Whoa, what a day. I mean, we got to learn a lot about Aurora's past, present, and the future vision. We went from a single database all the way to a distributed database, and then apparently we're going to continue to go.
That's the rumor.
That's the rumor, yeah. And we got a chance to talk to all the OGs.
We did.
All the founders, the folks in the field, the developers. It has been an incredible 4 hours.
It has. Personally, I belabored it. I talked about it. We talked about it before. The idea of being able to grow and evolve over 10 years is something we've had a privilege of doing. And it all starts with you, audience, chat, everybody out there. As you guys are iterating, leveraging, working on things, we want to hear that feedback so we can continue to go and build things to delight you and help you solve the hard business problems that you're running into. Because even just think about it, a distributed SQL database in seconds without infrastructure to manage, 10 years ago, 5 years ago, we'd have called you crazy and said it was impossible.
Yeah, for sure. I mean, we have seen the journey of this database going from just a wee little announcement product all the way to a distributed database. And it has all been thanks to you, to your feedback, and we always listen to you. So reach out to us via all the forums that we have. Reach out to your AWS contacts. Reach out to us directly. Come talk to us at Reinvent. All of us that you saw here are going to be there. Tell us what you want. Tell us what your wishes are in Aurora database and other AWS products. And we're happy to continue working on it.
Yep, and it's important to note that there have been many people along the way that have been inspirational or have had a direct hand or role involvement in how we got to this point. And I believe we've got some remarks from a special somebody, don't we?
Yes, we do have special remarks from Jitu Krishnamurthy, who is a VP of databases, and he's going to come talk to you. So please hang around for a minute.
Hi, I'm Jitu Krishnamurthy, VP of Database Services. Alas, we are reaching the end of the Aurora 10th anniversary celebration. What you saw today is just the beginning of what is possible when intelligence becomes more interactive, more context-aware, and more capable of acting on our behalf. We envision a future where our databases effortlessly work with applications and agentic AI systems, eliminating operational complexity while maintaining unwavering security, performance, and reliability synonymous with AWS. But what's been true over the last decade and will continue to be true in the future is that we are innovating on behalf of you, our customers. Thank you everyone for tuning in, asking questions, and staying with us through all the demos and deep dives. Your curiosity and your big ideas and your energy is what inspires our innovation. Thank you, Aurora teams from around the world, the United States, Canada, Ireland, UK, Germany, India, and Australia, whose customer obsession, dedication, and relentless pursuit of excellence has built this service trusted by hundreds of thousands of customers all around the world. For those who join late, we'll be sharing a recorded version of today's event. We'll have more demos, more builders, and more workshops at the reInvent in just a few months. Until then, keep building, keep experimenting, and keep imagining what's possible with Amazon Aurora. Thanks for joining us, and we hope to see you at reInvent.
And that's about all that we've got for y'all today. G2, thank you so much for those remarks. And yeah, I think you nailed it. Keep building, keep iterating, keep growing. And we wanted to call out, you do want to continue learning on this path with us. We strongly encourage you to check out the AWS On Air show every other Friday right here on these same stations at noon Pacific. And then also, we've got a real special episode coming up on the 12th of September. It's about a week ahead of my birthday. It's going to be the NFL special. We're going to go behind the scenes. There might be some on-field logistics and some other shenanigans with some of our hosts and one of our producers, Nick. But until then, Aditya, what do you think? You think we're done for the day?
I don't think we're done at all. I mean, we have our team to thank for today's episode. So, and we have a special cake, and I think we have confetti.
Do we have confetti?
Yeah. Where is it? There it is. Woo!
Thank you so much, everyone, for hanging out with us today. Please stay tuned. Please continue iterating. Go out and build something and let us know all about it. Thank you so much.
Thank you so much.